Alright guys, so today we got a chiller issue to look at. As you can tell on the left side of the screen, both chillers are enabled. I'm going to scroll up to, also one of our pumps are enabled. They usually only run one pump at a time. Also, one of the two chillers is dead, so we really only have one chiller. You can tell our return temperature is 69, which is a little too high for a chiller. And I know there's a history with this location, so I know we are off on some sort of alarm or safety or something like that. It's been sort of a nuisance for a while now, so we're going to check it out. Alright guys, we're down in the mechanical room here, just making our way over to the pumps, make sure the pumps are on. These are our air handlers, of course. VFD drives, really just a basic setup from what I can tell anyway. Now keep in mind guys, a majority of this stuff is still new to me. I come from light and medium HVAC stuff, and this is a little bit larger, so I'm still getting used to it, so don't expect a very detailed explanation. I will explain everything as I know it. I may be wrong on some things. Feel free to comment, give me advice, correct me, whatever you want. I'm here to learn and share the little bit of knowledge that I have, so yeah, feel free. Let me know what you guys think. So over here, obviously we have our pumps. Now that pump is off. It does come on once in a while. This system is a lead lag sort of system, so it does come on once in a while. This is the main pump that runs right now. I think it's yeah, for 27. So this is our return feed. We're sitting about 10 psi. As far as I know on this system, we want about 10 to 12 psi. So that's normal. Let's go over here and check our supply side pressure. Supply side pressure is 40, and it's flopping around all over the place, which is really, really odd. I marked it right there because that's normally where it sits. I marked it there over the summertime when it was running, I guess, just fine without any sort of issues. Our supply, of course. Our separator. Feed tank up there, although the feed tank has been, let me double check. Yeah, I know it's hard to see with that light right there, but the feed tank has been disconnected, so there's no actual feed going into it. You have to manually feed it. You have to, hook a hose up to it, feed it that way. So let's make our way out to the chiller. This is one of our returns. Oh, real quick, let's take a side step here. Now this, when I first started looking at this location, this was a little mind-blowing to me. We're standing inside the economizer, essentially. So right now, I know it's, I don't know, for you industrial guys, you probably know exactly what I'm talking about. I don't even really know what I'm talking about sometimes. But anyway, right now we are exhausting, because this right here is the vent that goes straight outside. I mean, as you can see, there's storage and shit. They just got some stuff stored out there. But we are actually exhausting, pulling air out of the building. We're not bringing fresh air in anywhere from in here. The other thing that was neat to me, I didn't realize, is this right up there. That's our ventilation shaft. Also new to me. Strange. There's another part of our mechanical room. All sorts of noises. These are newer air handlers. There's an air handler sitting right up there above us. We got some old steam boilers here. I haven't worked on those yet. Also, that compressor back there is providing air for the pneumatic system. They still run off of air-driven pneumatics. Some of them have been converted over to the electric motors or the electric-driven pneumatic systems, I guess. Or I guess, no, you don't want to call it the electric pneumatics. That doesn't make any sense. The electric-driven actuators, rather, instead of air-driven actuators. So it's slowly being converted over to the electric stuff. See you guys. There's the exhaust I was just standing in moments ago. Sorry about that, guys. There's certain parts where I'm just not allowed to film, or rather parts where I don't want to get caught filming. We'll say that. Right here is another part of our economizer that I was standing in a little while ago. Right here, this is our main chiller. Let's climb in here real quick. Yeah, coil's nice and clean. Water pressure is a little bit lower than what we were seeing at the pump. If I remember correctly, our return water pressure was like 10, and our supply was jumping around like 40. Our purge thing is all wet. It's not really wet. It feels oily. Interesting. Now, I've seen these before. I know what they do. They just purge the air out of the system. It's a really neat setup, actually. I don't know if I'm explaining this exactly right, but there's a little, like an upside down cup inside here, and as the air would fill up in here, the water level would rise, or the water level would fall rather, and that would allow the air to go up through this top part and then, you know, bleed off the top. And as that air bled off, that little cup rose, it would rise back up, and it would close this top part of the valve, as far as I understand it. Again, guys, I'm green to all this. This is all new to me. Super interesting stuff, though. So anyway, obviously you can tell we're not running, we're not doing anything out here, despite our system calling for cooling. There's my vodka bottle from this morning. Got to get your vitamins in early. That right there, that's our dead chiller. I don't know what's wrong with it. When I first got this account, I was just told that it's dead. Hasn't run in years. It's been bid to be replaced. That's all I know. Disconnect's still on, but I don't believe there's still power going to it. All right. So let's see if we can find the alarm. Evap, water freeze, 10:13. Looks like it was a little bit after noon, about 1 o'clock in Army time, 12:30 Army time maybe. Evaporator water freeze. So I'm thinking either low water flow through there, or some sort of scale buildup inside that evaporator that's slowing down the water, or maybe insulating the actual heat exchanger. I call it an evaporator. I think it's technically called a heat exchanger in this setup. I'm going to bring up the manual real quick and just check to see what the evap water freeze says in the manual, if there's anything specific that it notates on this model. So as you can tell, guys, I've downloaded the manual on this unit. The unit I have is an AGZ 125 something like CCH or whatever. So it's a 125 ton unit. Scrolling over to this. It doesn't really list a section of troubleshooting or alarm codes. So we're just going to search for the alarm that we have seen and see what comes up. Alright, seems to be some sort of glitch with this. Anyway, evaporator water freeze without glycol 36 to 42, with glycol 12 to 42. Now this system, I know there's glycol in the system. I don't know the percentage of glycol in the system. I do have some test strips. I do not have a refractometer to properly check the glycol, so I don't know exactly what I'll be able to accomplish, but I'll be able to at least test. I think I can test I can get in the range of what the actual glycol content is with these test strips, but again, a refractometer is going to be much more accurate. See, evaporator water freeze, trigger, evaporator low water temperature drops to evaporator freeze protect set point for at least the recirculation time, and low water temperature sensor faults is not active. Alright, well, so we know at some point in time the water in our evaporator dropped below 36 degrees. Again, depending on the content of glycol. It could have been, I think it was 12 to 42 from the previous screen. Doesn't look like there's anything else in this manual that's really explains evaporator water freeze. We're back at page 104. All right, let's go in here and clear this alarm, if I can figure it out. Alright, so we have no more active alarms. Now there's a delay in this system, so it might not fire up right away. So in the meantime, I'm going to go get my glycol test strips and go downstairs near the pump and dump out some glycol and see if I can check it. Not as long of a delay as I thought. Alright guys, I'm going to drain a little bit of the glycol water mix into my container, which is this old valve body I found, since I don't have any loose Tupperware containers on me. Exercise the gate valve. Smells like glycol. Now, let's just double check our directions here. Dip in for 1 second, remove, shake excess fluid off, yada yada yada. I'm pretty sure this is where Monster energy drinks come from. Could be wrong, but it looks about the same. That's about 1 second, right? Alright, acid corrosion protection, good. It's gonna be super hard to do with one hand. Told ya. There we go, let's do this. Let's test it again, just to be sure. To me, it looks like we're bordering on the 60% mark. Third time's a charm. Let's do it again. That first test, I didn't shake the fluid off like you're supposed to. 1 second. Yeah, I'd say we're closer to a 40% mix, which would give us freeze protection between -10 and I guess 260. We can focus. There we go. So I don't think our glycol mix is the problem. There we go. It's having some focusing issues. So anyway, so this assembly right here coming off of our return pipe, I used to call it a strainer, but after looking into it a little bit further, it's actually a strainer and a diffuser, I believe. There is a strainer aspect to it, but also a diffuser. Like I said, I have looked into that before. So I don't, and again, don't get me wrong, I'm definitely no expert at these at all, but kind of talking to a few other guys, if I did have a pressure drop, like if this was clogged up, I would expect some sort of pressure drop from it, you know, like I'm sitting at 10, and again, my pressure on the other side is a little bit wonky. Still at 40, jumping all over the place. But again, that's on the outside of our pump. That's on the supply side. So obviously our pressure will be much higher. Now, I'm not smart enough to know exactly what that pressure should be. I don't know the impeller size. I know I could probably deadhead it, do some sort of genius mathematical equations and figure out the diameter of the impeller, drain some water into a 5-gallon bucket, figure out the GPM, and then sort of go from there to figure out, I guess, exactly what that pressure should be. But I'm not smart enough to do that yet. So here's my suggestion, guys. Now you guys are following me along in my learning process, if you will. Now we're just about into winter season where I'm at, which means we'll be draining this system and winterizing it. So my suggestion to the customer is, once we drain the system, we'll pull that apart, clean it all out, obviously new gasket, everything, put it all back together, make sure the diffuser and the strainer are both nice and clean, and then also run some sort of cleaning solution through the evaporator, the heat exchanger. Maybe get like a white vinegar solution. Now my buddy Luke was telling me that we can get a white vinegar solution in there, throw a trash pump in a bucket and just circulate white vinegar through there, you know, changing it out depending on how dirty it is and how much crap we get out of the evaporator. So that's not a terrible idea. Yeah, in the meantime, I don't see anything else really crazy going on, but those are the suggestions I'll be making to the owners of this equipment. One of the other things is we don't have an actual water feed going into our feed tank. We can go up there. I don't know why, but it's been disconnected. I don't know if there is a reason. Is that a common thing? If you guys watching this know, is that something you guys do for any sort of reason? I don't know. Real quick, guys, let's get back into the program here. On the left side of the screen, you can see our return temperature is dropping. Started off around 69.5, 70 degrees when we got here. It's now 63.5. I believe this particular loop is set to 54, maybe 55 degrees. and it's only been running for about 20-30 minutes, so it's taking a little while longer to actually reach that set point. It's not too terribly hot outside or inside the building, so it should pull down rather quickly. That does it for today, guys. Thanks for watching. Again, give me any feedback, any comments, any tips, any information. Like I've said numerous times in this video, you're following me through my learning process. We'll see you guys on the next one. All right, in today's episode, we're going to be changing out this little compressor here on this little Hvac unit. There's our replacement compressor. I hope you can hear the Christmas church bells in the background. So yeah, anyway, this is what I would consider a budget job. The customer, I believe, is looking to replace this equipment once it becomes more readily available, but in the meantime, we just need to get it up and going ASAP. One of the technicians last night came out and diagnosed this. So yeah, we're just gonna go ahead and start cutting this thing out, or rather sweating it out. And then one of the other things I'm gonna do is I'm gonna cut the dome off this compressor once we're all wrapped up here and see what actually killed this compressor. Judging by the discoloration on this side right here, I'm assuming we had a fair amount of flood back at some point in time for an extended period of time. Not real sure. A couple areas of concern are a little bit of oil on a liquid line, but that could have just been from the previous technician removing his gauges. Now, if this was a permanent repair, what I would do, because I don't like these valves, they tend to leak, I normally cut those out and I straight pipe it through here with just a little service port or a new valve. I do the same on both of those. I would replace my sight glass along with the filter dryer. Even though the sight glass is fine, it's just something I like to replace if I'm doing the dryer as well. Also, that compressor isolation valve right back there with all the dirt on it, I would normally cut that out and just straight pipe that as well, just to prevent future leaks. And then I don't mind these pressure switches, but I would probably put in a mechanical one just so I can adjust it if need be. Condensing fan motor doesn't seem bound up. Whenever I do a compressor, though, I generally do a condensing fan motor just to be safe, because there's no point in putting a $1,000 compressor behind a $200 condensing fan motor that could fail. We'll do our contactor, of course, new start components. But like I said, guys, this is just a budget job. We're not getting too crazy with it. Customer doesn't want to spend a whole heck of a lot of money on it, so we'll be recovering the refrigerant. I'm going to test it for acid, and then we will be reusing it. I got my recovery tank over there. I'm going to pull a vacuum on it and get it ready. Down to 700 microns on a recovery tank. I like to keep the vacuum on there so the sides cave into my recovery tank. Then I know it's good. In the meantime, I'm going to do a quick little acid check on this system, just to make sure there's no acids or anything in there. Now, ideally, I'd like to do this when the system is running, but I don't have that pleasure. Just a quick little spritz on there. I don't know how well this is coming across on camera, but it doesn't seem to be any signs of inorganic compounds such as acid, so we're good to reuse this refrigerant. Again, guys, budget repair. System will be eventually replaced, so I'm not too concerned about it. All right, so let's get to work. Real quick, guys, on a side note, I don't have access to this walk-in cooler right now because the building is closed. So I don't know if my evaporator is running or not. Sounds like it is through this wall, but that could also be the walk-in freezer evaporator that I'm hearing. But anyway, we'll be pulling through both sides. Once we actually do pull a vacuum, right now I'm just going to recover everything. And again, I will be recovering from both sides. It'll be a little bit a slower process, not ideal, because we'll be pulling through that TXV and recovering into this tank, of course. But again, guys, real world situation. It's not ideal, but sometimes this is what we got to deal with. So right now, Got my machine hooked up. This is kind of loose. I'm just going to purge a little bit of refrigerant through here. Make sure we got all the air out of the lines. And then, yeah, we'll go ahead and set this to 0. And see how much we recover. Compressor's unwired. We're pretty much ready to yank it out of there. I got my low side pressure switch taken off right there, just to make sure I don't melt it. I cut the dryer out because I really prefer to cut them out whenever possible. Now, I mean, I do have to unsweat the little stubbies that I left on there, but that's all right. I can deal with that. We just got to come back here. I think I'm just going to wrap this line to protect the high side pressure switch and unbraze that side. And we'll pull it out, throw the new one in there, flow some nitrogen. That's all ready to go. And then we'll braze the new stuff in place. So we're all brazed up in place here. Everything looks good. My joints all look pretty good. Got to get my heat blocking putty off my dryer. I'll clean that up a little bit. This putty works pretty good. Keeps your dryer from turning all black and catching fire and whatnot. And the suction side looks good, looks good. All right, let's pressurize it and make sure we don't have any leaks. Well, we passed the decay test. Just pulling a vacuum on this. I know it's not the best setup for the vacuum tree, but it is what it is at this moment. I need to get a new set of gauges, by the way. But yeah, so we're down to about 800 microns. Doing good. I'm going to take this guy home, back to my shop, pop the dome off, pull the motor out, and see what we can see inside of that thing. Quick little truck tour, you guys. Just got this van, so it's still kind of shiny, kind of nice and neat and organized. You know, got everything just about where I want it. Just threw my winter gear in the truck here, so yeah, we're good to go for the winter time, bud. This is one of those unicorn jobs where you get to pull your truck up right next to the condenser. I mean, it doesn't get any easier than that. Flipping awesome, eh? We're up and running. We're pulling about 3.5 amps, 3.6 amps. Using my fancy dancy, is that a word? Anyway, using my Emerson mobile app, I scanned this, and I found the working amps for about 110 degrees. Now, right now it's like 45 degrees outside, so my amps are a little bit lower, I'm assuming because of that. But yeah, so that looks good. I'm happy with that. I don't know if you guys can see it, but our sight glass is full. A little cloudy because it's old and crappy. But yeah, satisfied with that. Got a 40 degree evaporator. About a 95 degree condensing temperature. We do have a headmaster on this one. Bypass valve. Does appear to be bypassing, so we're all good. Now, for any of my keen-eyed viewers out there, they'll notice that the walk-in freezer disconnect is off. I just spoke to the owner, and she says that's never worked. They would like to get it up and running, so I'll cross my fingers. We'll get to dive into another project. Now that one, if I get to touch that one's getting the big picture diagnosis. Did have to add a splash of refrigerant to it, a little over 10 ounces. Nothing too crazy, but I'm gonna wrap this guy up and head on the inside and see what our evaporator situation's like. Now, I didn't get footage of this earlier, but we were at 70 when I got here. We're at about 45 now. There's our evap. Yeah. That evap's pretty much shot. Whole system just needs to be replaced and done with. Check out this non-working freezer. Spooky. Climate control, everything is turned off. Evap coil looks better than the other one. Now, she said this system hasn't ran in 5 years. I mean, that's how long she's been here, so maybe it ran before that, maybe not, nobody knows. What is this thing? Rake him. Must be, oh, looks like it's some sort of heat tape. That's weird. Oh, that's the heat tape I saw on the drain outside. There's some heat tape running next to the drain. It's not wrapped around it or insulated whatsoever. It's just running next to it, which isn't going to be sufficient in the wintertime, but it's a good looking box. You know, everything looks nice and new and clean. Floor's not warped. Yeah, this would be worthwhile to get up and running for them. Then if they ever did have cooler issues, they could just pop the door open in an emergency and get them by for a little bit, and they wouldn't lose all the product, I suppose, like they did this last time. As you can tell from that last clip, the cooler's down to about 45. It's going to take another couple hours, in my opinion, to get down to 35, 38 degrees. So I advise the customer just to keep all the product out of there. They do have another cooler, which actually, I was trying to get some footage of it, but they have another cooler that's all wood because this building was built in like 1850 or something ridiculous, but it's a super cool looking cooler. And all their food is in there, so it's at temperature. I just told her, just give it a little while. I'm not familiar with this system, so I know we just changed a compressor in it, but if there's any additional bugs that need to be worked out, which I didn't see any signs of, I would rather have it happen with no product in there than with a cooler full of product. I don't want them to lose any more product than they already have. But yeah, we're all set here, guys. And like I said, I know this job wasn't pretty. It wasn't textbook. There was a couple things I would have really liked to do, but it's not a big picture job. All right. HVACR videos. By the way, you'll notice my fancy dancy merchandise here. Go check out my buddy Chris Stevens over at HVACR videos. Click on any one of his videos, scroll down. There's a link to his merch store. You can get super cool merch just like this. All right. But for now, anyway, like I was saying, actually, let's get back to what I was saying. It's definitely not a big picture sort of repair, if you will. Like I said, there's a couple things I wanted to do or would have liked done, but it's not in the budget. Looks like this equipment is going to be replaced soon, so there's no point in going through and doing all the other stuff that I'd like to do to prevent future issues as far as replacing valves, straight piping stuff, repiping this and that. There's just no point in doing it right now. So it is what it is, guys. Real world stuff sometimes. So be safe out there. We'll see you on the next one, all right? Here's a compressor from earlier today that we pulled out of that walk-in cooler. And what had happened was it seems to be physically seized up. Drawing locked rotor amps, it won't pump, tripping off on the overload. So what we're going to do is we are going to cut the top off this thing, pull the motor out, and see if we can figure out why it died, all right? So let's get to work. You can see our motor itself is mounted to some springs. We have our suction line right here, which we need to cut out of the way. All right, just a pair of alignment cutters right there. Probably fight me a little bit, because electrically we're still hooked up over here at our terminals, but we'll see if we can pop this thing out. All right. Yeah, oil looks black, looks old. Smells pretty awful. Yeah, it's some strong smelling oil there, guys. Let's get this out of the way. Get our cutting tool out of the way. Yep. That's pretty well seized up. First thing I'm going to do is change my gloves, and then we're going to pull the stator off. All right, there's our stator. Looks all right. I don't see any damage. Nothing seems to be burnt out on it. Looks like it would function. Right here is our rotor, obviously. See if we can get this out of here. Now this right here, let's see, what exactly would this be? Because this is going to be on our discharge side. It wouldn't make sense to be on our discharge side because it's got a port right here. I'm guessing that this would be some sort of internal accumulator, possibly. I'm going to set that aside and do some homework on it. Some sort of weird, mysterious little port right there. Don't worry, guys. My Milwaukee's in my work van. All right. Get these pesky little screws out of here. All right. Well, look at there. That's pretty fun. Now, that's definitely not supposed to be there. Now we just gotta figure out what the hell that is. So it's stuck in there. It definitely got smashed. Looked like it went right over here, right? These are obviously our reed valves right here that fit like so. And so this, oh yeah, there's our other one. So it would fit like this, right guys? And these little broken pieces, which I'm going to dig out in a second, looks like one went across here and then the other would go across here. So these would be our, let's see, as it's sucking in, these would go down. So these would be our suction reeds. And then it would compress and push out these side reeds. Maybe. Let's, yeah, it would have to. So it would have to suck in, pull these down, and then push out that away. Let's see. Let's separate this plate here. Yeah, so it was our discharge reeds have come apart. Interesting. So if you remember, guys, from that video, let's just put this right down here for a second. So yeah, if you remember, one of the things I noticed on the head of this compressor, on the top of it right here, and I could be wrong, but there's obvious discoloration right here, which I thought maybe was due to liquid floodback, which could definitely be our case, why our discharge reeds have shattered. What do you guys think? Get a close up there. Very nice. Yeah, she definitely got smashed. She got smashed pretty good. Now, I wonder if we can get this to turn. Yeah, she doesn't really want to come out of there. Oh, that's why, because it physically can't come out of there because of the wrist pin on the bottom. Gotcha. So we would have to remove our, let's see, we got to move our rotor. All right, well, let's remove the rotor then. All right, guys, I gave up on trying to get our rotor separated off the shaft so I could physically pull this piston out and look at it. What we can do is we can just push the cylinder down and we can get a pretty good bird's eye view of the inner cylinder walls. Yeah, I don't see any damage whatsoever. All the damage seems to be just on the head of this piston right there. So the other thing that you'll notice, the top of this piston is black, which I don't know enough about this particular manufacturer's compressor, but looking at the sides of this, the sides of this piston are, you know, a regular gray metal. So I'm assuming that the top of this has experienced some sort of high temperatures, burn or whatnot. So I wonder, I don't feel like the any sort of high temperature, like if we had loss of lubrication or say the condenser was dirty, I don't feel like that would have caused such damage in our plate, in our discharge reed, our discharge valve plate here. I'm pretty sure that we got into some sort of liquid pumping situation, and it obviously couldn't deal with it anymore, so it blew itself apart. That's what I think. Now, let me know what you guys think. Go ahead and put some comments below here. Send me an email if you want. CuriousHVACguy@gmail.com. But that's all for today, guys. Thanks for watching. Here's what's going on today, guys. We got this carrier unit that apparently doesn't want to heat sometimes, or at least it wasn't heating last night. It didn't come through as an emergency, so we're here this morning. As you can tell, I kind of got started without you guys, but I'm not too far into it, so let's see what's going on. I assume you counted 5 just like I did, so 5 blinky lights. So we had an ignition lockout failure at some point in time. Now the unit's heating right now, so, and then the other odd thing too is that as far as our thermostat goes, it was satisfied when I was downstairs. Not sure why it's heating right now, but I'm going to double check for a signal for heat. Who knows, maybe in the 11 minutes it took me to get out of the building, walk around to the back, get up on my ladder, and then walk across the building, maybe it's calling for heat again, I guess, but I doubt that. So, yeah, condensing coils really, really bad. Gonna have to have that cleaned before summertime. Oh yeah, look, it's really bad over there too. But that's got nothing to do with what we're doing now. So let me get my meter out and start chasing some stuff down, start chasing some voltage and see where we're at on this guy. Let's go to our common. Our W right there. And 25 volts. And it literally just shut off. Let's see, maybe we are satisfied. Huh. Such superb timing. So yeah, so we are satisfied right now. Let's shut that off. I'm gonna let the blower run for a little bit. I'm gonna pull the blower panel, check out my pulleys, my bearings, my blower assembly, the belt, all that fun stuff. And then I'm going to get back there, I'm going to pull this panel out, get back there and inspect the ignition controls, or ignition system. Flame sensor, sparker, all that fun stuff. Sounds like our blower just went off, so make sure that's off. We'll do a quick voltage check, just because I don't want to be electrocuted. Make sure we are actually off. Let's see, this wire goes here. This is extremely difficult to do with one hand. All right, so we should be good. All right, the first thing I notice is the edge of those burners look all rusted up. I'm gonna pull these burners out and check the end of them, because let's see, where is it at? So what'll happen is ignition will start on this first burner, and then via a little channel in front of these burners, it will ignite across all 3 burners and then prove the ignition over there at the flame sensor. So if we're igniting over here, but because of this channel being rusted or blocked by anything, what will happen is it won't be able to actually sense ignition over there. So let's pull those out real quick. Alright guys, now this is how I pulled the burners out. They pretty much came out in one piece, right? So I'm going to slowly flip these around and try to explain what I think I found here. So looking right here, you can see that channel, but you see right here how that channel really isn't there. Well, what has happened is this burner right here should be in the middle, and then this burner right here that has this side blocked off should be over here, because this one in the middle needs to be able to spread the flame from here, which this one is in the correct position, so the flame spreads through this channel, and then it would, you know, go through here, and then it would go all the way through this one. Of course, this one's blocked off because it's not in the right spot, but if this one was right there, it would go through there, then all the way to the end, and then we would prove ignition. So that's definitely an issue right there. The other issue is these are in pretty rough condition, so I'm going to recommend they be replaced. I'm going to just drag my knife or screwdriver just through this channel and just clear it out a little bit. Kind of make sure there's nothing blocking it. But yeah, these burners definitely need to be replaced. The flame sensor and spark igniter look pretty good. I was told this heat exchanger's been replaced, so I assume those were replaced along with the new heat exchanger. But I'll throw a dollar bill on them, clean them up a little bit, edit that. So yeah, there's our flame sensor, spark igniter. Those look pretty clean. I was told this heat exchanger's been replaced, so I'm going to venture to say that those were probably replaced with the heat exchanger, because those look pretty darn new. I don't think there's really much I'm going to be able to clean off of those, so I don't suspect that's the problem. Again, I suspect that our burners being in the wrong position is the problem. Real quick before I put these back in place, guys, this is how they should be oriented. If you can tell, that middle one is now an open channel which bridges this left burner across here over to the right one where we could properly prove flame. So I'm going to clean these burners up a little bit like I said, and we'll put them back in and then just verify that they do fire up without issue. And if there is an issue, well, we'll figure that out too. Alright, burners are back in place. I get my light to work here. It's not really going to do what I want. Then we got number 1, middle, and then the third one over there. I also cleaned up some of this rat's nest of wiring. Got this cleaned up too a little bit. I don't know if anybody else noticed this, but somebody has moved our W2 over to our W1 because this thermostat bundle is only a 5-wire. So yeah, it's just a 5-wire. So that's weird. I wonder why they ran 5-wire. I mean, I guess whenever it calls for W1, they're going to get W2. They're going to get high heat no matter what. So I guess it is what it is. At this point in time, I'm sure the customer doesn't want me to run new thermostat wire downstairs for that. All right, let's move on to the blower, see what's in there. It's probably a blower. Well, it's a little dirty, but not crazy terrible. Belt's not really dry rotted. It's definitely been here. It's definitely done some work. I'm going to recommend we replace this drive pulley. You can feel the lip is worn away down inside there. Blower pulley is not terrible. I'll throw a zip tie on there. I think what I'm going to have them do is, summertime we got to come out and fully clean that condenser. And with this being a barbecue joint, a smokehouse, I'll bet that evaporator over there is pretty dirty too. We'll pull the filters in a second and check it. But I think in the summertime, what I'm going to recommend is we clean the condenser, pull the blower, put a new belt on, replace that drive pulley, and as well, we'll clean the evaporator. We'll give them that huge picture sort of service. How do people ever get filters out with one hand in videos? That's ridiculous. It's not terrible. Not terrible at all, actually. You can see right through that coil. Huh. There's a little bit of crud on these filters, but that's weird. Oh, I see. It's been bypassed the old-fashioned way. Gotcha. Gotcha, gotcha, gotcha. Verify the seat exchanger is good. Still looks pretty good. I don't see any weak spots in there. Along these little indents right back there, that's really where I focused on. But yeah, there's nothing back there. I know you guys can't really see it right now the way the light's hitting it, but take my word for it. Let's see if it fires up before I put all these panels back on. Producer, spark. Well, it didn't seem to hesitate at all to fire up, so I'm gonna call it good for now. We'll quote those parts over there. The drive pulley, and also make our recommendation for early spring to get this guy cleaned up before it becomes an issue. All right, thanks for watching, guys. We'll see you on the next one. Here's our issue today, guys. Walk-in freezer, not maintaining temperature. Obviously our fans aren't going around. We're at 38 degrees. Coil, it's nice and clear. This thing looks like it's new. Well, at least they spray foamed it. At first I thought that was frost buildup, but it looks like they just put tape over that hole and then they probably spray foamed it from the top. And it's calling for cooling. Our fans are most likely off because of our fan delay isn't satisfied, but there's not any ice buildup. So we got to figure out what this condenser is and go from there. A little crack right there. I'm not too concerned about that for now. For now, anyway. All right, let's go find the rooftop here, guys. Here's our condensing unit. RDI. I got no action going on in here. No compression, no nothing. Just a quick peek around, see if maybe there's any obvious signs of oil leakage, but I see nothing, so. All right, pop this panel open, check for voltage. We should have 208, 230, three-phase coming into the side there. Alright, so check this out, guys. We got a 214 there. Got 89 volts on the outer two legs. Then on the middle and the right side, we got 135. So we obviously don't have correct power. I can hear something humming, which looks like our contactor maybe partially pulled in. Yeah, I'm not real sure. But what's weird is this thing. I've never seen one of these before. Okay, it's just a junction box. It's a weird junction box, man, I tell you what. So I had the power off. I just came up here after I clicked the breaker off and just rechecked my connections inside the wire nuts. I switched out the wire nuts. They had these little red ones on there. Nothing wrong with the wire nuts. Seemingly nothing wrong with the connections either. I just wanted to make sure. So those are all checked. I'm gonna go back downstairs and I might pull the cover off the breaker panel and just inspect that breaker, because the breaker wasn't tripped. Or at least I couldn't tell if it was tripped. It didn't look like it was tripped at all. So another thing I wanted to do before we climb all the way back down and climb all the way back up, just on the slight chance that this unit was tripped for whatever reason, we're just gonna see if we have anything directly shorted to ground right now. There's our load side, nothing. Excuse me, no, this is our load side. The other side was our incoming power side, nothing. Contactor looks decent. There's some signs of wear on the contact points themselves, but nothing I'm overly concerned about. And right now I got nothing shorted to ground in any way, shape, or form. So let's continue this, go downstairs and check our breaker. All right, there's our freezer breaker. Let's see. All right. We got power there. The breaker's bad. Well, that's no good. Got the new breaker. Man, these things are expensive, dude. Like 500 bucks. 500 bucks for this breaker. Yeah, so it is what it is, right? So let's go back, change this breaker, then we can figure out if there is anything else wrong with the system. Fingers crossed there isn't, but you never know, right? All right, new breaker's in. Double check power again. 215. All right. That looks better. All right, 215 all across the board. Now, put the cover back on, and then we'll go upstairs to double check the condenser, see what that thing's doing now. Didn't get a chance to point this out inside, but this is a nifty little Klein insulated screwdriver set that I got that I use on live applications like this. Really good. I recommend you either get this one or get yourself a set of Klein screwdrivers so you stay safe out there. The van's a little discombobulated at the moment. Got my Curious HVAC guy cart, a bunch of other random stuff. I don't know what any of that stuff does. All right, let's get on the roof. All right, I can hear it running from here as we trudge across this frozen tundra. Feel some heat coming out. Compressor sounds good. Coil's nice and clean. Condenser's off. Why is our condenser off? Well, it's fan cycling. Oh yeah, there's no headmaster on this one, it doesn't look like. So that's super special. Our sight glass looks good. Let me get an amp draw the compressor here in a second. We should be pulling blah blah blah. I'm probably pointing right at it, yeah. So 10 amps. Let's go over to this side. One continuous shot. How about that? All right. It's hard to do one-handed, guys. We are going for... Sorry about that, guys. Took me a minute to find compressor wires. So we're pulling about 7 amps, right? Not bad. You know, something else that I want to do is, now that my leads are all nice and snowy and wet, I want to test across this contactor right here. So let's get this meter set up. We'll go like this. How about that? Let's see. Now I should have, pretty close to 0 amps across it. 0.9, 0.2 or 0.02 rather. So yeah, I'm gonna say that contactor's not bad. All right, we're down to 6 degrees, guys. 6.9 degrees. I'm actually surprised that it dropped this fast. It was about, I don't know, 45, 50, whatever it was when I got here. And they said it had been down for about a day and a half, and I kind of assumed it'd take a little bit longer to come down to temp, but it is a small box. And the product's slightly thawed, but it's not bad. So yeah, just so you guys know, if you eat at this particular restaurant, I might be fingering your food. Mmm, yummy. All right, so let's end the video by tearing this thing apart. It's very shaky. It's definitely got shaky stuff inside. So, yeah. Let's hit it with a big ass hammer and see what's inside. I got some of these long, what I would call long rivets, drilled out. Got the sticker taken off the top so we can separate the sections. Now, I don't remember exactly which which one of these was giving us problems as far as voltage goes. I know one was giving us, I think, half the voltage. One wasn't giving us any voltage at all. I know in your world it seems like that was just moments ago, but this is actually the next day for me. So we're going to start by drilling the rest of these rivets out, and then we'll go through and open up each one of these and see if maybe, I don't know, the contact points inside are just burned out. So the first one, I believe this is the one that was on all the way to the left of the 3-pole part of it. It kind of fell apart once I opened it. Spring popped out. Yeah, it wasn't a clean break. What I'm really looking for is like burnt contact points. I don't really know what I'm looking for, honestly. I was just hoping to see something that's obvious as to why it's not working. No. Alright, that's garbage. Let's go to this one. Let's see if maybe we can carefully... Hold on, guys. Let me put the phone down real quick. So this one was a little bit cleaner of a break. You can kind of get a better view of everything as is inside of a breaker. I'm not really a breaker expert, but I know we got a bimetal in there that heats up and shuts things off. So this is our lug that goes from the power point inside the breaker, the power where it screws down to the bar. I don't know what you call it, the electrical bar, whatever you want to call it. So that's energized. And then, see, it looks like this right here. If we can get down in there. It doesn't look like that is making contact inside there. And if I had to guess, this piece I'm assuming is some sort of something to dissipate heat, of course. Yeah, so as it sits, I guess it's... Yeah, so as it sits, it doesn't look like it's making very good contact in there. But then again, as it sits, it's me taking it apart, so I don't know, honestly, what sort of damage has incurred from me just taking it apart, but... All right, let's see what this one's got going on in here. Contact point looks nice and clean. Right down there is where it makes contact. Well, I don't know. Maybe I should have took it apart a little slower, but I was expecting more. I was expecting burnt stuff, melted stuff, stuff that looks cool. These contact points don't really look bad. I mean, this contact point does look kind of bad, but I've seen contacts far worse, and for example, contactors. Thanks for watching. Like I said, I was hoping for a little bit more of a climax from this, some burnt stuff, some cool stuff, but hey, you know what? It is what it is. It was still a pretty cool service call. Glad I got to share it with you guys. But yeah, that's it for now. Stay safe out there. We'll see you soon. Walk-in freezer day today, guys. 30 degrees. Walk-in freezer. No bueno. What the hell is this? This floor is terrible. Yeah, immediately. Holy shit, look at that floor. I hope you guys can see that. That is wild. Well, those are all frosted up. Fans obviously aren't moving. Everything's froze up. Drain's nice and warm though, so that's cool, I guess. Can't really tell if our fans are froze up due to ice buildup or if that's the cause of our ice buildup. So we'll have to get a ladder and look into that a little bit more. Get right over there in that corner. You see right there, right along that wall? That big, giant open seam with the rust spot next to it. Yeah, that's probably not great. Well, you know what I just noticed too? Ah, there's a door back here. Yeah. Door is closed, so I don't care about that. Kind of peeking around this product. Let's get my light out here. Yeah, I mean, it looks like it's closed and sealed up best it can be all the way around there. Whatever. That floor is just wild to me. There's got to be so much ice underneath this floor. Right there, it's just heaving right up. Wow, you know, if it's heaving up in the center, I bet the sides of this box aren't sealing properly. Let's check it out. Yeah, don't be scared, guys. Every restaurant looks this way, but look at this threshold. Look at it right there. See that? How it's rising up like that? But look over here. Look all around that wall. The floor is separated from the walls. That is just crazy. I've never seen that before. The actual floor is separated, or the walls are separated from the floor, but yeah, either way, that's not cool. That's not doing a very good job of sealing anything, is it? I mean, look at that. I can reach right in there. I can reach right into the wall of this freezer. How is that going to maintain proper temperature? So another thing here, guys, if you'll notice, this door doesn't want to close right. Mostly because the way this floor is heaving up, it's pushing up on the outer frame of this box, obviously. You can tell by the edges right there. I mean, look at... I mean, even right there, you can see condensation coming through from, obviously, warm air infiltration. Dude, this box is just shot, man. So yeah, so this door doesn't want to close properly. I mean, I can't even find a flat place to set my ladder. So anyway, our evapes are pretty much freed up. With my light. My light was right there. Why don't you guys tell me that? Jerks. Crunch, 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 crunch. Alright, so our evap isn't frosted up as bad as I thought it would be. Which, since our fans aren't going, it leads me to believe that maybe we're low on charge. Because with our condensing unit, or we've just been cycling off on low pressure, I guess. That could be the other thing. But with our fans not going, I would expect to see a lot more ice buildup back here, a lot more frost. I would venture to say that our fans are probably just off on our defrost termination fan delay switch, which I think is going to be over there, maybe on this side, or over there. I don't know. We'll figure it out. I'll bring you guys back here once I figure out a couple things. I stretched my hose out in here for pretty much nothing. So I got my hose ready before I took a peek at the back, assuming that it'd be frosted up. But yeah. Let's pop this side panel off and see what we can see. All right. Well, it took me a minute to get this side panel off. You see why? Because it's fucking frozen, like the Ice Age. Bent that a little bit, but that's all right. That'll buff right out. No problem there. So I just took my Widowmaker and just my non-contact voltage detector, just checked all these wires. I don't have any live voltage that I'm aware of, so I'm gonna very gently spray some hot water in here, get as much of that crap out of there as I can, and then yeah, we'll move on and keep, I guess, diving into this mess. This is definitely not going to be a permanent solution whatsoever. Here we are, still melting ice. This entire side panel just packed full of ice. Which, by the way, if you guys don't have one of these wands, get them from Lowe's in the Home and Garden section. It's perfect for this application. Like, I'm just going slow and steady, man. Just letting the water go down the drain. I'm not making a huge mess. You know, it's probably the best way to do a dirty job like this. So, go out and get yourself one of these. Highly recommend it. Still trying to get to my defrost termination fan delay switch way back there. But a little bit more to go. I got pretty much all the ice out of here. Right down here, guys, this is our heater safety switch, right? Right here, the red one. And then right up here, this sort of yellowish, waxy looking one, that is our defrost termination fan delay. Now, I'm not sure how well you guys can see this, but there. So if you'll notice that lip right there, right on the back side there, where it looks like that yellowish sort of waxy portion of it is coming out of the body of that. So what that usually indicates is that the switch has failed. The defrost termination fan delay has failed. Most likely has moisture inside, and that moisture over time freezes and expands, and it pushes the sealant, whatever that is, the polymer, the waxy looking thing, whatever that is, it pushes it out. And then in doing so, it also interrupts the contacts. I don't know if it actually pushes them out or somehow it keeps the contacts from closing. Obviously, if it's frozen inside, the contacts can't move, and therefore our fans don't come on, which is cool. But we can easily bypass that. And in this situation where we have a heater safety in place, I can bypass that defrost termination, and if worst case scenario my defrost clock seizes up in mid defrost, it won't stay in defrost, or well, I mean, it will stay in defrost, but at least our heaters will cycle on and off, because what I'm going to probably end up doing is bypassing that defrost termination fan delay for now, just to get my fans running. And with this particular customer, this is something we'll have to quote. So, but first, let's get over to the other side and make sure that's all thawed out That's our TXV side. Not much to see over on this side other than an uninsulated sensing bulb covered in ice, which obviously is not ideal whatsoever. Also our drain line, no insulation around that. I mean, at least throw some foam tape on that bastard. I'd even settle for cork tape at this point. Yeah, this thing's a mess, dude. Just a mess. I mean, honestly, a big picture diagnosis wouldn't even work on this. It's just too big of a job. There's no picture big enough for this deal. You know what I'm saying? So yeah, we're gonna give him a big picture quote, but yeah, I mean, this box alone is just shot, though. I mean, that's my biggest concern. I mean, I got gaps everywhere in this box. Got my defrost termination fan delay bypassed right here, so I essentially just have power going to my fan circuit whenever the evaporator is energized or whenever the cooling circuit is energized. So right after defrost, my fans will come on. That's not ideal, but I want to do that now, just to get them up and running. Also, you'll notice that you didn't see me test that defrost termination fan delay, but just based on experience and how the plug of that is pushed out, I don't trust it. I'm not even going to bother testing it. I'm just going to bypass it and quote it to be replaced. Also, wire nut sealed up nice and tight, and I'm going to point it straight up so it's not going to be upside down, so it can't hold moisture, or as much moisture rather, because I don't want it to fill up like a cup inside that wire nut. Then I'm going to go through and just double check all of my spade connectors, make sure there's nothing rubbing out. Yes, we're going to be quoting, so far we're quoting that defrost termination fan delay. I'll quote to re-insulate that line, the drain line, as well as the sensing bulb over there on the other side. I can't get over this box though. Like, look at that. Tip of the day, guys. Whenever you're washing out an electrical cabinet like this, or electrical controls like this, take a shop vac, put the hose on the other side, just blow all the air out, or blow all the water out from around those terminals and everything. It does a pretty good job. Don't put the hose on the sucky side, put it on the blowy side, and then you can blow all the water from around the spade connectors, really decrease the chance of anything shorting out once you turn it on. Remember, no sucky side, blowy side. And blazam, we got blowers. Alright, so next up, let's kind of take a quick peek at the condensing unit up on the roof and see what kind of condition that is in. Alright. This is our glorious walk-in freezer condenser. Of course. One over there too, huh? Alright, hold on. Let me take these out real quick, guys. Yeah, she's rough, man. Of course, we're running HP 80, which I don't have in my truck, which is real stupid. But yeah, that's neither here nor there. I mean, really, this whole system needs to be changed out. But here's the issue, guys. I'm not even going to quote to replace the system because that box is in such horrible condition. I don't want the liability of replacing all this equipment and then still having all of these issues with the warm air infiltration. But I guess maybe I'll just talk it over with the customer and kind of let them know my concerns. At the very least, if I notate my concerns and they decide to go against them and just do new equipment instead of a whole new box, you know, that's on them. At least I said my piece. But I mean, to replace this box, I'm standing on top of the walk-in freezer right now. I don't know how much space there is above that walk-in freezer, you know, between the joists and the top of that box. There isn't much, I know, but I don't know what it would cost to even replace that walk-in freezer box inside this restaurant. It's wild to me. So anyway, guys, we're gonna let this thing run. Sight glass is nice and clear. I'm just gonna let this thing run and watch the temperature, because I have a lot of other crap to get to today. All right. Another super sketchy thing over here. So this is their outdoor panel. Not locked, just hanging out right out here out in the open for anybody to play around with. Box temp, according to this crappy thermostat, is 19-ish. I just can't get over that floor, man. So let's see, we're down to about 10 right there. Again, guys, this box, it is what it is. It's not going to be perfect, but we're getting down to temperature. All right, so enjoy the show. Thanks for watching. Hope you got something out of this, guys. We'll see you next time right here. Walk-in freezer, 25 degrees. There's our floor. There's our intelligent unit. This apparently is a newer system installed by somebody else, not me. Hold on, let's get a light back there. Looks like this ceiling's leaking mashed potatoes. Oh no, that's just spray foam and lots of foam tape. Damn. I thought I was good at insulation, but man, whoever did this is fucking great at installing insulation, man. That is amazing. It's got to be what do you think, like 3/4 roll of foam tape? Anyway, that's not why we're here. We're here because it's 36 degrees in here. Let's see what our box settings are. Set point is 0. Refrigerant 448. Alright, so honestly not much to see down here. Fans are going. It is apparently calling for cooling. Actually, you know what? I almost forgot. Let's see what our EXV is set to. Go to monitor. I just want to see if our EXV is open. Position 255, suction pressure is 13, suction temperature, coil temperature is 38, huh? Alright, well, they say it's programmed for 448, however, that's not always the case. It could be programmed over there as 448, but that may not be what's actually in the box, so yeah, let's jump up on the roof and see what's going on at the condenser. I believe that's our walk-in cooler. This I'm 93.2% sure is our freezer. I didn't do that, I found it this way. But let's pull that, oh, I don't even have to pull the cover. It's already open. Look at that. It's not like this is outside or nothing and the wind would blow it open and then rain would get all over it. Look at that, that's pretty sweet, huh? Alright, let me grab my meter, I'll swing over to that side and we'll start checking some stuff out, alright? Oh, this has got one of these DTC valves. Yeah, interesting. Been a while since I've seen one of those in the wild. I like these bone units. These are pretty pretty good unit for the most part. It's got its quirks. It's got its little things that I don't really care for, but you know, whatever. Could be worse. It could be a train unit, right? Right? Am I right, all you train guys out there? You know I'm right. You know what really makes me mad though? So nowhere downstairs is it written down what refrigerant is in this unit, right? So, and I just had this issue the other day. These are all the refrigerants that it can take. Boom, right? Nothing written down over here, which would be cool, you know. So let me just take a paint marker, jot it down, or like what I like to do is, you know, write it inside the cabinet somewhere here. You know, so the sun doesn't get it, rain doesn't get it. I got nothing over here. Walk-in cooler short cycling. I'm sure that's set up and running optimally. Oh yeah, nothing written down over here. Yeah, so the only thing I have to go on is they programmed the evap for 448A, which the other system I ran into the other day is doing all sorts of funky stuff, and I'm pretty sure it's actually got 404 in it, but the system is programmed for 448A, so I quoted to pull the charge and then charge it up with 404 and just go from there. But yeah, let me get my meter out and start doing some stuff. All right, I'll bring you back in a minute. Right here's our pressure switch. Yeah, 210 volts. That means my low pressure switch is open. So I'm hooked up, and I'm not sure how well you guys can see this. So my low side's at, what is it, 13 PSI. High side is at 217, which would be about a 92 degree condensing temperature, but it's almost like we are pumped down. But we shouldn't be pumped down because the electronic expansion valve was, what was it, at 255 steps, and our set point is 0, and our current box temp is 38 with a 2 degree differential. So we shouldn't be pumped down at all. I mean, if anything, we should be equalized right now. I'm back down in the box trying to figure out why the upstairs unit is essentially pumped down. And I got to noticing, look at this amazing drain. Awesome. Shark bites, pecks. Giant chunks of ice. I'm guessing they had a drain issue. So yeah. Awesome. Alright. So two things I wanted to point out here. Our electronic expansion valve is opened up all the way, 255 steps, but also our board voltage is only 23 volts. Not sure how well you can see that, if you can see it at all, but our transformer is tapped for 240. So I'm going to shut this off real quick and switch that around. And that's after we switched the transformer taps from 240 to 208. So the board now has 100% proper voltage. Let's see if anything changes. So this is a little hard to show you guys, so I'll just tell you what I did. So right over here is our electronic expansion valve. It's hard to show you because I have a wall right here. You know, there's not a lot of space. And so I was just checking the electronic expansion valve because I suspect it's got issues. According to the manual, boom, right there, you're supposed to check resistance at the pins on the valve itself, right up there. But I can't really get to that now, can I? So, yeah. So all I did was unplugged it, and I checked it over here at the Molex, where it goes into the control board, and I got 137 ohms. It says it should be 150. at 75 degrees, so since we're at about 40 degrees, I'm just going to assume that our windings in the electronic expansion valve are okay. But we're essentially still in a pump down state at our condenser, and I don't know why. But anyway, I checked the windings of the electronic expansion valve. I even pulled the little Molex off the top of the electronic expansion valve stator just to make sure that it was positioned properly. After talking to tech support, which by tech support I mean Chris Stevens from HVACR Videos. He's amazing. Shout out to Chris. You're the man, Chris. I do appreciate all your assistance. Which, by the way, if you guys ever do want to call Chris, you have to have one of these fancy Bluetooth earpieces, or he won't answer the phone. It's just simple as that. So yeah, I went through. Windings are good. They're 137 ohms. The manual states that they should be 150 ohms. I apologize for the wind, guys. I can't control it. I tried to mentally control the wind before, but it doesn't work. Anyway, it's just stuck. It's just stuck. All right, guys, it's just stuck. That's just the way it is. So with that being said, I got to get on the horn with some supply houses. No, that's not where I'm at, by the way. That's the restaurant across the street. But yeah, so I got to get on the horn to some supply houses, see if I can open one up and get an electronic expansion valve. So if I can and when I can, I will bring you guys back, all right? So hang tight. All right, guys, we are back. It is Monday. We're back on this walk-in freezer deal. The electronic expansion valve is stuck shut. I did come back here Saturday, the day after I was here for the initial diagnosis. I came back Saturday and attempted to do the job, but got rained out. Even though I had a tent and all the other fancy shit, I still got rained out. Now Saturday, I got the charge recovered. Right now, I was able to put a holding charge, just some nitrogen, back into the system before I left Saturday, so there's no refrigerant in the system right now. I am going to change the dryer again. I did change it before. When I was here Saturday, that was the last thing I was able to do was change the dryer. I'm going to put a little bit of an oversized dryer in there. Plus, I don't like the piping that I was able to do on the fly in the moment, seconds before rain started pouring down, and hail, by the way. So yeah, I'm going to do the dryer, make it look nice, get my manifold hooked up. We're going to be using our True Blue hoses. We're going to do the whole 9 yards today, guys. I got our nitrogen flowing. New dryer's piped in. I opted to just replace this entire elbow. Quick side note, because when I was here Saturday, the thunderstorm hit. I had a tent over me, so I kind of rushed this filter dryer install. And honestly, I didn't like it. It held pressure. Don't get me wrong, it would have worked just fine. But it looks like garbage, and honestly, I don't want to put my name on this. It was a rush job in a very unique situation. Lightning, thunder, rain pouring down. I had to get it in. I was trying to get the job done, but I just couldn't do it. And like I said, it did hold pressure. It just looks like straight garbage, so I didn't want to use it. So I'm not going to. So I just cut it out, and this will be no charge to the customer. This is just something that I want to do before I put my name on it, all right? And to my boss, if you're watching, I owe you a filter dryer. How about that? Let me give you a quick preview of what I'm about to do, because there's no way I'm going to be able to film anything because I'm right tight up against this corner. So let's slide over here. Got my old valve cut out, and then I'm just going to unbraze these nubs and then kind of manipulate this distributor, fold it over a little bit, and then braze in the new valve body, and then we'll put on the solenoid in a minute. But in my opinion, preparation to braze is almost more important, if not as important, as the brazing process itself. You know, I got all my wiring out of the way. I got the control board moved out of the way. It's hanging there by some wires. It's safe. I'm going to be aware of my surroundings as I'm brazing, of course. And over here, this pile of nonsense. Essentially everything I think that I'm gonna need while I'm brazing, I have it within arm's reach. I have some water, I have a fire extinguisher outside the view of the camera, of course. I got my Hvac, which I'll put on the new valve. Everything I need, I'm ready to go. Okay, I'm prepared to braze. That's very important. You don't want to get halfway through brazing and then stop and then put more heat to it. You want to get on it and get done. All right, so that's exactly what I'm going to do. I'm going to braze this in place, and I'll show you the outcome when I'm done. Here we are. The electronic valve body, anyway, is brazed in place. And braze joints came out pretty good. In hindsight, I wish I would have took a wire wheel and cleaned up the old braze, the old solder, before I sort of reused it on the new joint. I did put new silver in there, but I always find it better if you just take a wire wheel and clean up that old joint before you do it, and I didn't do it this time. But I was flowing nitrogen, so we should be all set. I got my screen in there as well, so I'm going to run up on the roof, crank the nitrogen regulator up to purge, and make sure we're actually sealed up. I think while this is pulling down, it's a good time to start getting some stuff cleaned up and organized around here. I just started the charging process. I've added 12 pounds so far. The receiver is 6.8 liters, which comes out to be about 14.9 pounds. So I did about 80% of that, which comes out to be about 12 pounds or so. Now, right now, you'll notice we're all frosted up. I literally just turned this thing on, so my Hvac downstairs isn't cold enough yet, so my fans downstairs aren't running, so this is normal. I got no worries about this. Tried getting my camera turned on a few seconds ago, but I was trying to highlight the rise in pressures that I was seeing. Line set hasn't really been hit with all my superheat yet, but my pressures went up because my fans downstairs are finally turning on. So give it a second, our pressures will equalize to where they should be. It's probably, I don't know, about 60 degrees out here, 60, 65-ish. So my head pressure will probably be about 85, 90 degrees. So we're looking pretty good. My box temperature right now is about 50, 55 degrees. This box has been down for 2-3 days now. So our low side pressure will be a little abnormal for the time being. But like I said, that is to be expected in this situation. It's getting there. So guys, I was here a couple days ago fixing this walk-in freezer unit, right? Now, if you guys have seen this video, it was kind of a little bit of a debacle. It was an emergency, and I got rained out, and I came back and needed a new electronic expansion valve, right? So a couple days later, I got a call on this, the walk-in cooler is getting warm. So I'm here today working on that, right? And then I noticed this mess right here. Obviously, it's not supposed to have all this ice on here. So what I found is, I went downstairs, put it in service mode real quick, watched the electronic valve steps down to 0, and this continued to run. In test mode, what I found is, as the control board was opening and closing the valve, my voltage was, initially it was way too low. I was getting like 24 to 25 volts from the board going to the electronic expansion valve, right? Keep in mind though, I do have 26 volts going to the control board from my transformer, which is absolutely 100% correct. Now there's a capacitor on the control board that helps drive that electronic expansion valve open and close, apparently. So anyway, in test mode, I watched it go around 3 or 4 times. First time was like 24, 25 volts, second time 26, third time 24, 25, and then like the last one was real low, like 4 volts. And according to tech support, just some food for thought, I'm supposed to have 37 volts to open and close that valve. So apparently my control board has gone bad. Yeah, I've been on the phone all morning trying to find one of those. It's almost like they're just non-existent in the U.S. Now you guys probably can't see that, but right now I'm just entering service mode. You go to test mode, enter the code all nines, 99999, and now we're slowly entering service mode. And what this will do is it will go through and energize all the relays. It will also send power from this Hvac plug to my electronic expansion valve, and that's what I need to monitor. Actually, while we wait for that to happen, just verify proper voltage down here. We have 27 volts going into the control board. Right down here where it says 24 volts, 24 volt return. Bottom of the camera right here. Defrost relay. We don't care about that right now. We're waiting until it gets around to our electronic expansion valve relay. That's what we want to see. Fan relay. I hate that fan relay. Super annoying. Alarm relay. Also don't care about that. Liquid line solenoid relay. We don't have a liquid line solenoid, of course. Our electronic valve acts as our solenoid in this system. So it must be the next one. I guess I was wrong. I don't know when it's going to be. It might not even be in here. Who knows? 23 volts. So yeah, I should be getting 37 instead of 23. Alright, let's shut this down, change this board. Alright guys, new board is in place. Interesting thing is I just heard that electronic valve shut and the condensing unit upstairs just powered down. So that makes me super excited. We just got to configure the new board. Eastern daylight saving time, we'll say yes for now. Date, time. Low temp electric, definitely. We're gonna go on demand. We got 404. Suction temperature, we want suction pressure. So we're pumped down at 12. I'm not going to mess with that too much. That seems fine. Like I said earlier in the truck, I usually keep it around 5 to 8. So 12 isn't bad. I'm going to leave this right here. So once our electronic valve opens up, we can watch our suction pressure rise. And the condenser is maybe 4 foot above me right now, so I can hear it start. Is our suction pressure rising? It should hit about 25 to 30, I think our cut-in pressure is. Alright guys, so what I'm going to do is I'm going to run upstairs and just verify that the compressor's running. 900% sure it is because we're at 28 PSI. And then I'm going to come back down here, put it in service mode, let it pump down and verify that the condenser does pump down and shut off. Alright, so let's go for a walk. Here's our condenser. It's running. It's froze up. Because it's been running non-stop for a very, very long time. So, one thing I'm going to do while I'm here is defrost this. Shut it off and let it defrost for a little while. Now let's go back downstairs, put it in service mode, and we'll make sure it pumps down and shuts off. Alright, we're in service mode now. This thing's got some weird little quirks. Like one of them is the extended amount of time that it takes to get into service mode. Box temp, set point differential. I'm going to change it to 3. I just like 3 better. Alright, let's run upstairs real quick and make sure we are off. Alright, we are off. Yes, we are still frosted up. I'm going to just let this sit here for a little while. Let some of that ice melt off there. Alright, so hopefully that's the last I see of this unit for quite some time. Now, one of the things I didn't get on film in the initial part of the service call was when I condemned the electronic expansion valve on this unit, I did check for voltage going from that board into the electronic expansion valve cable, and I did get 37 volts, but I didn't get it on film. So I'm sure a lot of you guys are like, well, you know, the electronic valve probably wasn't bad. Based on my findings, it was. Now, did that board crap out after I changed that expansion valve? There was a storm that moved through the day I was here. Maybe. I don't know. Did that have something to do with it? Maybe. I don't know. I'm going to tell you the story as I pace back and forth on the roof. The other thing is that evap coil is tied into this condenser. Now, does that make a huge difference? Maybe. I'm not sure. I know factory, they want it wired on its own circuit so that the surging of the compressor, the locked rotor amps on startup, doesn't affect the low voltage going into the control board, since it's tied into the same circuit. Does that make a huge difference? I don't know. I'm not an engineer. But I have heard through the grapevine that those little things can have some wonky effects on these. Again, I don't know for sure. So, I don't know. But I do know that initially I did get 37 volts to my expansion valve, and it wasn't moving. It wasn't opening, it wasn't closing. And I changed it, and then it wouldn't drive open or shut with the board. So, I mean, honestly, it could have been both. I could have just had a bad board that at that very instant that I was checking voltage, I got 37 volts, and then the rest of the time it wasn't. That electronic expansion valve could have been good. Like I said, maybe that one time I tested, I got 37 volts, whereas the other times I was only getting 23, 26, you know? But the point of this matter is we got them up and running. They got a new valve, they got a new board, and I learned quite a few lessons along the way. And for all those out there wondering, I mean, we did make multiple visits to this. Obviously, I'm not going to be charging the customer for every single time that I was here for all this nonsense. I mean, don't worry about the billing side of this, guys. Just look at this video for what it is. a little bit of educational material showing you the steps that I went through and the horrifying nightmare that I lived through. Alright guys, that's all for today guys. I'm out of here. There, parting shot of a fancy York unit. Enjoy. What's up YouTube? How you guys been? Missed you, by the way. Haven't really had anything real interesting to film in quite some time, so I apologize for that. But today, we got the first no heat call of the year. So it's raining outside, it's cold, it's gloomy. Perfect time to be up on a roof, hanging out with you guys, and trying to fix some heat, alright? So let's get after it. Alright, well, after quizzing 17 people who work here, I was told this is the unit that needs some attention. The one with the butter knife on it. It's an older unit, I don't know, what do you think, 10, 15 years old probably? It's got a condenser fan, look, there's a compressor. It's got all your classic things on it. I don't have access to the thermostat at the moment, so we're going to find the thermostat wire, see if there's a current call for heat. If not, we will initiate a call for heat. Actually, you know what? Let's check that heat exchanger first. Well, I forgot which panel accesses the heat exchanger, but look what I found. It's like Madagascar up in this thing. I don't see anything alive in there. But, you know, it's pretty dangerous. Highly flammable pile of sticks and whatnot right next to some open flames. Not cool, birds. Not cool. Alright. Let's get some eyes on the heat exchanger first. It's actually in much better condition than I expected. I'm gonna get my light down inside there, way down at the bottom of those bins. Some discoloration down there. Appears to be mostly surface rust. Alright, step one, remove giant bird nest. Check. Step two, check for 24 volts. Check. Step three, check for 24 volts on our call for what I assume is heat. Check. Step four, check for lights that will give you the answer of what's wrong with it every single time. And we have no lights. Well, shit. Alright. Gotta dust off my brain on this one. Alright, so I unplugged it and plugged it back in. Inducer came on. Pressure switch is closed. And we have fire. So now, why wasn't it heating? It's a good question. Let's let it run for a little while, see what happens. Maybe after it runs and runs and runs all day, inducer goes bad. It's gonna amp draw our inducer. Or inducer doesn't go bad, I mean the inducer seizes up once that bearing gets hot. Amp draw 0.5. Rated at 0.7, so I mean that doesn't really make much sense. I know my blower is going. I already checked that. That was going when I got here. Interesting. You know, I don't know why it is, but I tend to get more of these calls where you go there and you turn it off, turn it back on, and it runs fine. And then you leave, and then it stops working. Flame sensor looks pretty good. End of it's a little tarnished, but I did move the spade around. It's nice and tight. There's a clean connection point underneath that. I went through and tightened up all my thermostat connections. Let's pull that spark igniter. Pull the sparker, see what we can see in there. I don't see any other loose wiring or anything. Well, let's just keep on checking wires. There's our ignition, our spark assembly, spark igniter. Really doesn't look bad. I know on camera here it looks a little tarnished. That's just a shadow. Actually, let me see if I can get a... Yeah. In real life, though, it doesn't look bad. You have to take my word for it. The spade end here looks right there. That looks a little suspect, but we can scratch that up and get a better connection point right there. Well, I wish there was a way to give them a big picture. There's our big picture bird's nest. Supply is 134. Our return is about 84. It's obviously a pretty high return, but I'm not actually measuring it in any sort of ductwork. It'd be great if I could measure it from the diffuser downstairs, but I don't have access to the space we're heating, actually. Really all I'm checking is my temperature rise, which on this unit is 30 to 60. So we got 84 to 134. Yeah, within tolerance, right? So far, no idea. No idea what the problem was. Let's see if our inducer maybe is creeping up on amp draw here. Nah, it's about the same, 0.4, 0.49. Yeah, it's real weird. No odd noises. Obviously, this unit isn't equipped with self-diagnostic components, so no idea, man. We may just chalk this one up to a lucky day and a boring video. Alright, so yeah, hit that like and subscribe button if you guys want to see more boring videos like this. Yeah, I don't know. What's up, guys? Got a no heat call today. I'm just at this bar hanging out. Nobody's here yet. They're not open. So I got secret access to this place. So anyway, I'm gonna go over here, covering up the business name. The thermostat set to 73, heat mode, all that fun stuff. 68 in here, not terrible. There's a wire that goes up there. I was told this is a new unit that was recently installed like a month ago. So let's go see what's going on up there. First, I'm gonna pull that thermostat and just double check the wiring. I doubt that it's wired wrong and it somehow also ran good for a month, unless it's been running okay in AC mode, I suppose. So yeah, we'll check that out. Shit, I don't have any quarters. Let's see what I can get. What do you guys think here? Oh, it's not terrible, right? Bullseye. Let's do it. No. Alright, let's get back to work. Man, I tell you, that was an adventure. So I finally figured out the secret handshake to gain access to this secret back area. There's my roof access. But I love old, abandoned, dirty areas. Look at that, there's a rooftop unit back there. t-shirt thingamajig. Bunch of other weird random things. Old broken cell phones. Huh. I mean, how did they get a rooftop unit in here? I mean, it's just sitting on the ground. You know, they have like a gang of Amish people coming here to lift it. Alright, well, let's quit horsing around. Get up on the roof here. Alright, well, I had to walk 9 miles across this entire strip mall, up and down varying levels of rooftops, but I made it. So this is our unit right here. As always, I always check for codes before I do anything with powering it off. Alright, we got a 5 for 5 deal right here, guys. Ignition lockout. Now, why would we be locked out? Check. Gas is on. Yeah, gas is on up here anyway. Hopefully it's on down there. Yeah, another thing that was odd is the downstairs. I'll put a screenshot in here, but downstairs, the OB wire was connected at the thermostat for a heat pump, or reversing valve rather. And obviously we have a gas pack. There's no heat pump or reversing valve or anything like that up here. So, I mean, that looks correct. This is for our smoke to the common. Okay. I'm gonna stare at that a little while longer, but anyway, let's reset power, see if anything happens. One, two, three, four, five. Bang. I hear a humming noise. Not sure where it's coming from. It might be coming from our blower section. Our 2 contactors for the compressors are pulled in, obviously. Our relay for the blower. Well, can't really tell if that's pulled in. So let's pull the cover off of this. Make sure everything's good inside there. There's our noise. It's just the fan noise from the Hvac drive. Alright, well, no biggie. Alright, let's carry on. I'm going to put this back. Put this cover back on, and then we'll verify a call for heat and go from there. Alright, I got a jump around here. Since this was a new install, I wonder if this gas valve is ever turned on. Oh, the gas valve is on. Well, shit. Thought it was going to be something cool. I mean, I can tell we're sparking. We're just not getting any gas, I don't think. Alright, let's see if we have actual voltage going to our valve. I got one side jammed in here for a ground because I'm doing this one-handed. Come on now. Alright, well, we got power to the valve. One thing I did notice as I was coming up onto the roof, there's a lot of new gas meters, a lot of looks to be electrical upgrades. A lot of these spaces in the strip mall are being remodeled and reconstructed, so I wonder if we even have gas going to this line. So I'm going to crack that union and give her a sniff. And then depending on how that goes, I'll have to get out my manometer and check pressure at the valve. So yeah, let's give her the old sniff test. I don't recommend this either, guys. It's very unsafe. Manometer's hooked up. We're going to check the inlet side first. I did crack the union, and it did pass the smell test. There seemed to be a fair amount of pressure behind it, so I didn't mess with that too much. Alright, so we got, what do we got here? About 4.5 water column inches, or no, wait. Sorry, we got 8 inches of water column. Let's power it on and see if that magically disappears. I've seen in the past, if we have like regulator problems, that'll just disappear once it opens up. Alright, real quick, should have had this all set up, but let's see if I can do this one-handed on the fly. Just verify we got 24 volts when it starts sparking. And we do. And our gas pressure is not fluctuating. Alright. Let's turn this off. Now we will check the outlet side, where I assume I will have nothing. Gas is back on. Manometer is hooked up to the outlet side of the valve. Let's see what happens here. This time I'm going to measure the main pilot, MP, and common, just to make sure I do have true 24 volts instead of checking at the ground. I can even feel the valve itself clicking open, or something inside is clicking open, which is really weird. I'm getting nothing. Nothing out there on my outlet side of this gas valve. I just missed it, but I did have 25 volts right there. Huh. Weird. It's been a while since I've had an actual bad gas valve, you know? Yeah, interesting. But you know what I just realized? So I had 8 inches of water column on the incoming side, and I'm pretty sure that's pretty high. Regulator 3.5. Yeah, so I wonder. So I'm just thinking out loud. So I wonder if maybe my incoming pressure is too high. I mean, there's no regulator on this unit, so that could be a thing. Or I'm just hallucinating because I've lost so much blood from where I sliced my finger open. All right, let's see over here. Words and stuff. Gas supply pressure 13 inches max, apparently. Let's see, manifold pressure 3.5. Alright, so 13 apparently is the max. So we're not, I mean, we're not too far away from that. We're at 8, so if it can handle 13, it can handle 8. Bizarre. Alrighty, well, I'm gonna make some phone calls to the owner and see what to make of this. See if they want to replace that gas valve or just go all winter without heat. You know, I'm assuming they want to replace the gas valve, but let's see. It's not that old of a unit too, so it might have some sort of warranty left, possibly. Looks like it's a 22. Huh. Killer bee. All right, well, we'll see you guys on the next clip where I will presumably be replacing that gas valve. What's up, guys? So it is the following day from the last clip that you saw, and I am just prepping to replace this gas valve. Got the new one right here. Look, box, part number, blah blah blah. So I'll go ahead and yank this guy out, put that other guy in, and see if I was correct. Now, as you saw previously, I did use my manometer. I verified there's no gas coming out of the outlet side of that gas valve. So, I mean, I'm 97% sure I'm correct, but I haven't changed too many gas valves in my career. They just, in my world, they don't go bad as often as people think they do. So I was sort of second guessing myself, but I mean, I went through all the proper checks and procedures, everything I could muster up. So let's get after it. All right, new gas valve is in. Got my temperature probe over here in my supply. Now it's cold enough downstairs, I shouldn't have to go screw with the thermostat at all. I should have a call for heat sitting there waiting, and we do. And we fired right up. Good. Alright, we're already pumping up some heat. 65. Temperature rise. Anybody know the temperature rise on this thing? It's probably like 30 to 60 degrees. 35 to 60. 35 to 65. It's probably, if I had to guess, 60, 65 degrees downstairs. And keep in mind, it is a bar. It is locked up. I haven't been down there yet. So we're just going to let that heat for a little while. I'm going to let it warm the space up, and then we'll go ahead and call her a day. I got a spare belt. I'm going to leave a spare belt in here for the winter, just to make sure we can avoid any dire emergencies in another situation. Because this, let's see, where am I standing? So this one is this building, that goes to this building, and that split system. So I think this location, judging by the footprint up here, they've kind of combined multiple spaces into one, but I think that rooftop belongs to them for the kitchen, and then this is for the entire dining section, bar area, all that stuff. That's garbage. I don't even know what the hell that thing is or what it does. It's a mystery. And I believe they probably have a split system too with the fancy locking caps. Looks like there's no huffing and puffing for me today. Ooh. You know what's better than finding tools on a job? Finding old Nerf footballs. Look at this. Oh, it's a Whistler too. Oh yeah? Well, let's see. Let's see. Yeah, you like that, Tom Brady? You fucking punk. Almost tripped. See how, you can't even see how far I threw that, can you? Alright, enough dumb shit. Let's get back to work. Yeah. So 88, we're almost at that 30 degree mark as far as temperature rise goes. So, alright guys, well, thanks for watching. Alright guys, that does it for me today. Thanks for watching. Much appreciated. Alright. I will hopefully see you guys real soon. As soon as I get something else really, really cool to film. What's this? Like right there. You guys see that? That's the EPA. They must have seen me up here. Right there. Yeah. They must be checking out. Make sure I'm using all my recovery stuff and my vacuum gauge and whatnot, right? Anyway, thanks for watching, guys. See you on the next one. Stay safe out there. Hey, what's up, guys and girls, guys and gals? So I have a sort of little special announcement. I don't do this very often, but my best friend, Chris Stefanovic, I'm sure you guys are familiar with his work from HVACR videos, has gifted me with some special gifts to give away, to pay it forward, if you will. So he has given me 2 $400 True Tech gift cards, which I am going to be giving away to one of you guys. So, how do you win these? You might be wondering. It's nothing crazy. I'm going to be giving them away. Let's do January 13th, Friday. I'm going to give them away live on the HVAC Overtime Show. If you're not familiar with that show, just look it up on YouTube. It's a little show that me and my buddy Chris, Adam, and Joe, we all do together. It's a pretty fun show. It's just kind of, we let loose, let it all hang out sort of deal. I'm going to give it away live on there. You don't have to do nothing special. You just show up and make sure you're in the chat, because I'm literally going to scroll through the chat and I'm going to pick 2 random people and I'm just going to give them away. Nothing too crazy. Don't have to jump through any hoops. But let me remind you guys, this is all from Chris Stefanovic. This is something he does every year. This year was a little bit special because he wanted to include some other YouTube content creators and obviously his best friends, which is me, because me and him are best friends. If you don't believe me, just Google it. It's true. It's common knowledge. We're best friends. But, you know, despite all the horrible things I do to Chris and how much I pick on him through the years, like, oh, yeah, there was this one time I paid a homeless man to sneak into his house, right? I told him, like, you know, make a nest up in the attic, stay there. But every day, I told him, the only way I'm going to pay you is every day you need to sneak down out of the attic when Chris and the family are gone, and you need to move all of his stuff on his desk over an ½ inch. Just do that, and I'll pay you $100. And actually, come to think of it, I never told that homeless guy the joke was over. He might still be there. Well, shit, I gotta make a phone call after this. But me and Chris have sort of always had a beef. We've been best friends, but we've always had a beef. Behind-the-scenes beef, because, you know, he likes to be all snobbish and think he's better than everybody sort of thing. There was this other time. I paid the postal guy, paid off the postal guy, because I knew Chris and his wife had submitted one of these Ancestry DNA tests. So I paid off the postal guy. He gave me the test when Chris and his wife mailed it in, and I had the results changed so it looked like they were siblings, and then I mailed it back to them. So for a good 2 weeks, I think Chris was dealing with the fact that he found out that his wife was actually his sister, which is amazing because they do kind of look alike, which is creepy. But I also found out during that time, Chris has some real stepsisters sort of fetishes. So that's weird. But I mean, had I not done that, we would never know that, and now we know. So it was a good thing that I did that. There was another time. I called the police in California. I called the police, and I filed a missing persons report on myself, right? I said, you know, I'm missing. Of course, I didn't say I was me. I just said, you know, this Curious HVAC guy is missing. The last place he was known, he was hanging out with Chris from HVAC videos at the symposium, and now he's just gone. And then what I did is I photoshopped myself into some of Chris's pictures in the background, and then I anonymously sent those to the police. And they kicked in his door, and they raided his house looking for me. The joke was on everybody because I was at home, just sitting there, just playing it cool, you know? And then this other time we went to the symposium together, and I remember I replaced his body wash with Elmer's glue. Oh, that was probably my most favorite prank that I pulled on Chris. Replacing his entire bottle of body wash with Elmer's glue, which, by all means, I mean, that was the best of the two alternatives. He was sticky for days, but It's better than what I was going to replace it with, which was horse semen. But, you know, that would be a little bit too far. Still hilarious, but the Elmer's glue was much, much better. Just to watch him come out of the shower thinking something was wrong because all his skin was peeling off. I think as he was crying, laying on the floor, I think he said something like, I'm molting, and he's peeling off all this, what he thought was his top layer of skin, which was obviously just Elmer's glue. But man, that was hilarious. Yeah, all that to say, Chris is a super cool guy. Every year, like I said, he does this out of the kindness of his heart, just to pay it forward to the world. So make sure you guys get over to his channel, show him some support, come over to the HVAC Overtime show, and see if I pick you to win. All right, guys? Stay cool out there. We'll see you soon. Not sure if that ever works, but feels warm in here. That's working, that's working, that's working, that's working, that's working. They're all spinning the right way. Thermostat set to 38. Let's come over here real quick. Not terrible. I don't know if you guys can hear that, but you can hear a distinctive hissing noise. Liquid line isn't real warm. Suction line's warm. But I don't know if that hissing noise is from... It doesn't sound like a hissing noise as if TXV is trying to feed without having a full column of liquid. Almost sounds like there's an active leak, but again, I got a lot of fans here spinning around. Alright, gang. Well, there was some talking before this, but apparently it's been so long since I made a YouTube video, I forgot how to use my phone to record stuff. So, you're seeing this, I don't know, midway through the diagnostic process, right? So, let's fast forward a couple steps. My sight glass, it is all bubbly. I was just about to take a look at my headmaster, right back there, and check the pressure setting of that, and then compare it to my high side pressure, which right now we're looking at about, what is that, 160. This is R404. So we're sitting about an 80-degree condensing temperature, which honestly, for this temperature outside, isn't bad. We're probably not too far off. I don't see any oil stains up here. A little bit of a backstory. I am familiar with this system. At one point in time when that system was being changed out, this one accidentally got pulled off the roof, mistakenly thinking that this was this. You know what I'm saying? This condenser is actually for a walk-in freezer across the other side of the building. The line set goes in and then over. This line set goes right there, and directly underneath that is the evaporator. So I'm not real sure how that happened, but it happened, right? So just get over it, all right? So I'm going to build a bridge, and I'm going to get over it. And I'm going to move on to the next step in this process. And that's going to be to zero out my scale. And then I'm just going to feel around on this headmaster control. Yeah, I mean, there's not much heat coming through there at all. Discharge on the compressor is barely even, I mean, it's warm, but it's not hot. So yeah, we're pretty low. Anyway, I know my story's all over the place, but back to my original story. So this unit was removed and then reinstalled once they realized the mistake of they pulled the wrong unit off the roof. And what I'm guessing is that it wasn't charged properly, so we're probably just missing the winter charge. So, alright, let's get into it, because I have another cooler to look at while I'm here as well, on the other side of the building. So, let's see what we can find out. Alright guys, so we're going to move through this one pretty quickly. I added about a pound and 9 ounces in there roughly. The headmaster control back there is a 180, so we should be sitting about 180 psi on our heads, our high side, which we are. Our evap pressure is up to 75, 80, sitting at about a 39 degree evaporator. So not terrible. Like I said, it's probably 52 degrees in there. The display is broke, so I'm going to take one of my temperature probes down there and see what we got. But up here in Michigan, we just got hit with like an Arctic blast from Canada or Czechoslovakia, I don't know. But it like crippled my whole area, so I don't have much time to spend on this. I did go through, contactor looks good. No defrost clock in this one. Everything on that side looks good. Normally what I would do is I would pump it down and just measure where that refrigerant level is using a heat producing device. But what happens is it's so cold out here, once I pump it down and put a MAP gas torch to it, it doesn't do any good. It's just too cold out here. And I don't have an infrared camera on me right now to actually measure the liquid level of that receiver. So I'm not going to do that today. What I am going to do though is take my electronic leak detector right there and I'm going to sweep the system, see if I can get any hits anywhere. But like I said, I'm 90% sure what probably happened is this unit, when it was reinstalled, because it was mistakenly uninstalled, it wasn't charged up properly. So, but I'm going to take that down to the evaporator, make sure that hissing noise I heard wasn't an active leak or anything like that. You know, not that I have supersonic hearing. I kind of feel like it'd be obvious if I had a leak that big that I could hear it. I'd be flat. The entire system would be flat and I'd be off on low pressure. But we weren't. We're just a little bit inefficient. So let me clean up my gear, run downstairs. Oh yeah, by the way, sight glass is full now. We're clear. Solid column going to my TXV. So let's clean up some gear, go downstairs, and then we'll sweep it real quick with the electronic leak detector. All right, boys and girls. Before we go, don't forget to hit these with the old beepity beep. Oh, what's that? Is that for real, yo? Or is it just because I'm banging it around on this? Hold on. It seems to be extra sensitive today. Look at that. It's going off right over here. I got a low battery, though. That's not helping. What the hell? Getting false readings, dude. Come on now. Alright, let me get some fresh batteries in there. Alright. Got fresh batteries back in the old beepity beep. Alright, so we got nothing there, so we're good. Alright, let's go downstairs. Well guys, I don't like the look of this. I see oil up in here. Let's see. There's a little bit of ice on there from being undercharged. Alright, maybe it wasn't oil that I saw. I'm not getting a hit on nothing. That's enough of the beep beep beep. Yeah, I thought I seen a little bit of oil residue right there on top of the TXV, the power head. But I guess it's not a leak. So anyway, I'm gonna real quick spray that frosted coil down, that frosted distributor tube down with a little bit of hot water, and then we're gonna hurry up and move on to the next fire we gotta put out. So, gotta move. It's a busy day. All right, distributor's clear. Let's hit it with a beepity beep. Just to be sure, I wanted to get the ice off there, the frost, and then hit it again. What was that? I got something over there. Maybe. Alright, well, let's confirm with bubbles. See if we got something for reals. I'm not finding nothing. Nothing I can confirm with bubbles anyway. Sorry, close up of my hand, I know. Look, it's already frozen on there. But I wonder if my leak detector is just getting wacky on me. Well, is that a growing bubble? No, it's not a growing bubble. Alright guys, well, let's move on to the next fire. I'll make note of what we did here today, and I guess we'll just have to see what time does for us. You know guys, I've really been trying to quit drinking the last couple of years. I've been sober for, oh gosh, I don't know, 5 years now? And then I get to work in a place like this. Yum yum, gimme some. Nah, no worries, I don't care about that. Anyways, let's get to work here. Let's see, solenoid, coil's clear, box temp currently is 46, I believe. Can't really see over there and see what the temperature set point is, but I see a screwdriver, which is never a good thing. Makes me wonder if anybody was over there poking around with that thing, adjusting the temperature like sometimes they do. So I'm gonna have to move some stuff, gain some access, see what the temperature is, and then we'll get up on the roof. There we go. If you guys can hear me, we're set to 35 now. Alright, so what I was trying to say there is I set that to 35. It was at 40. This is a keg cooler, so I want to keep it a little bit below 40, you know, closer to 32 if preferable. So we set it at 35 for now. Solenoid did click open and closed as I was playing with the thermostat, so obviously that's not a 100% foolproof way to tell if the solenoid valve is actually working, but 99% of the time, if you open and close that thermostat, cranking it up and cranking it down, and you feel a loud snap or a thud coming from that solenoid valve, chances are it's working. So let's get up on the roof. And here we are, by the magic of editing, we're up on the roof already. Here's the condenser, turbo air. So far, nothing obvious. The one thing I did want to show you guys, let's look at this sight glass together. I don't know how well it's gonna come across on camera with the glare and everything. But this is one of those situations where it's kind of hard to tell if it's full or if it's completely empty. Now, I think it's completely empty. Because if I look real close and I stare at it and I kind of blur my eyes a little bit, I can see what appears to be some sort of vapor moving through it, but I could be completely wrong. Because again, we're sort of keeping somewhat of a temperature. We're at 50 degrees in that box downstairs. Now this does have a headmaster again. Oh, where is it? Yeah, there it is. Peeking out right behind this receiver. I almost said condenser. And it's a, what is it, an LAC 4-180, so it should be maintaining about 180 PSI. Now, let me grab my gauges, and we will hook up to it real quick, see if we're low or not, and then we will go from there. Visually inspecting, I don't see any signs of oil anywhere. That doesn't mean there's not a leak or anything like that. Now, the history on this unit that I'm aware of, I was out here several months ago in the summertime, and I pulled the charge and I weighed it in according to 80% of the receiver volume. So should have been pretty close to having the complete charge in there, the winter charge and everything, unless we do have a slow leak somewhere, which is entirely possible. It's an old building. It's been retrofitted many, many times. So there's no telling where this line set actually goes once it goes through the roof. You know what I'm saying? Anyway, enough jibber jabber. Let's get some gauges on this beast. I mean, we're not sitting too bad. High side is right about 180 PSI, which it should be because that's what the headmaster is rated for. Just about 80 degree condensing temperature. And my evaporator temperature is about 15 degrees. Thermostat's set to 35, so my low side is a little bit lower than I feel it should be. Normally I like to see a 10 to 15 degree temperature difference from the actual evaporating temperature to the saturation temperature of the refrigerant inside the evaporator versus the temperature it should be, which again I have it set to 35 as a mechanical thermostat, which can be flaky, but it hasn't shut down, it hasn't satisfied and pumped down or anything like that. So only thing I see is low side is a little bit low. I might add a splash of refrigerant here and just see if my low side climbs a little bit, because depending on how much, let's say the refrigerant was low, depending on how low that charge was, our headmaster should still be able to maintain for the most part a 180 psi head pressure. Obviously that varies depending on exactly how low the charge is. I can't imagine you could be substantially low to the point where your sight glass would appear empty and your head pressure would still be maintaining 180 psi. I don't think that's a possibility, especially since it's like Arctic temperatures outside. But my evaporator temperature just seems rather low. Like, I'd like to see it around 20, but I mean 15 isn't terrible. Thermostat set to 35. Right now it was, or actually when I left the box it was 46 degrees. So currently right now with it, let's say it was still 46 degrees in there, which I've been up on the roof for maybe 20-30 minutes. Chances are it didn't get down, temperature didn't get down too far. But let's say it's still 45 degrees in the box. I'd want to see my evaporator right now at about 30, maybe 25. That's the extreme point, but a 15 degree TD is pretty sufficient. It's within tolerance, I'd say. I don't know, what do you guys think? Throw some comments down below if you disagree. This is all just rules of thumb, by the way, guys. I'm not claiming this is end all be all sort of thing. It's just rules of thumb that I operate by. Obviously, if I were to call Turbo Air and ask them, they would probably have something different, maybe something more specific, but it is what it is. Just to be sure, I actually do have a full column of liquid. I took the cap off my king valve and I loosened the packing nut that's on there and I cranked it all the way in, shut it down. As it was pumping down, I saw the sight glass slowly empty. Then I cracked it back open and I saw it refill again. So just a little trick you guys can do in case you're unsure. But yeah, everything up here looks pretty good. I'm gonna go back downstairs, check the TXV. Again, we might just have a flaky thermostat that was adjusted to 40, but has a drift of, let's say, 5 degrees plus or minus. So I'm gonna go downstairs, crank it down to 30, and just kind of see what happens. See if it slowly trends to a cooler temperature. You know what I'm saying? While I'm up here, give everything else a quick little inspection. Nothing rubbing. These look pretty good. I mean, overall, nice clean unit. Nothing too crazy. We'll get in here, check the contactor real quick. Contactor looks good. Actually, I know it's good because I changed it. I put all new starting components in here. Like I said, back in the summertime, new defrost clock. I pretty much replaced everything in there, so yeah. Potential relay still looks good, so no worries. But anytime you're out on emergency calls, or let's say you're in a position like I'm in where you just have all these fires you have to put out, take a few extra minutes and just kind of look over everything. You know, it might prevent another call the next day, you know, because you're already busy enough. You know, I get it. We might not have enough time to do the whole big picture thing all the time, or the biggest picture, you know, which is my new catchphrase. HVACR videos, if you're watching, you can suck it. My new catchphrase is the biggest picture diagnostics. No, wait, let me rephrase that. The biggest picture diagnosis. Mwah. Yeah, suck at HVACR videos. So yeah, we're looking good. Let's go downstairs and see what's going on. Well, guys, we're back up on the roof. I was downstairs watching the temperature drop. Got to 37 degrees, and then it shut down. So I got kind of worried. Came up here, and it was just in defrost. So just to keep it running, I cranked it out of defrost. The time's not going to match up, but it is what it is. I wanted to keep cooling right now to try to get that beer back down to temperature before it gets too warm. So it's got a lot of work to do. It's a pretty full beer cooler. You know, probably a couple hours it's going to take to get down to temperature, but we were at 37, 36. I cranked the thermostat down to about 32, but again, that is a mechanical thermostat, so I advised the manager to keep an eye on that, because there's a little bit of drift with those mechanical thermostats. I set it at 32. I don't know, it could shut off at 34, could shut off at 30, you know. And then there's also a 3 degrees differential in there from the time it shuts off to the time it kicks back on. So that thermostat, I did change that as well, so I'm not too concerned about that. Not to say that they don't go bad after a few months, but we're just going to keep an eye on it. Right now, all I can see wrong is that the thermostat was set to 40 degrees, and we're maintaining 46 degrees. So, I mean, somebody needs to keep their filthy hands off the thermostat, I guess. You know what I'm saying? All right, guys, thanks for watching. If you have any questions, comments, put them down below. All right, we'll see you guys on the next one. Stay safe out there, stay curious, and we will talk to you again soon. Well, hello there. Fancy meeting you here. Let's try that again. Well, hello there. Fancy meeting you here, my friends. Hey, what's up, YouTube? Welcome back. It's been a while. I've missed you. I assume you've missed me. If not, I'll get over it. I'm sure I will. But I have missed you guys. I've missed doing this. And today, I actually have a service call that may or may not be worth filming. If it's not worth filming, you'll probably never see this. If it is worth filming, you might see this. I'm not sure yet. But we got a walk-in cooler or a walk-in freezer, I believe. The work order is kind of messed up. So I haven't been inside yet, but we're going to be doing something with something. All right, some sort of walk-in. I'll be walking into something, most likely a problem. And before I get started, check out my cool hat. If you guys don't follow me online, check out the HVAC Overtime Facebook group, as well as the HVAC Overtime page. Make sure you subscribe to my YouTube channel and the HVAC Overtime YouTube channel as well. But this hat right here, everybody who's out there watching, right now is the only one known to exist. It's a 6-panel HVAC-R by my buddy, Chris Stefanovic. What up, yo? I convinced him to make some of these dad hats, right? Because as you can tell, I'm bald. And these dad hats are really, really, like, they conform to my bald ass head. I really, really like them. They're super comfortable. They're not like preformed like a trucker hat. They're just very, very aerodynamic. So I can run faster. I can swim faster. I mean, it's just so much better. So apparently, Chris Stefanovic said he's going to be releasing this on his merch channel or his merch site, his merch website. So I assume that he will, because he's usually not a liar. So go ahead and check out hvacrvideos.com and check out his merch store. I'm pretty sure that's the website. I don't know. But all you got to do is like Google, just simply Google best HVACR technician in the world, and it'll come up as Chris Stefanovic with like a million links to his merch store and everything. So, I mean, if you can't find him, then I don't know, you must be living in Zimbabwe or something, or Canada. Those are both basically the same places. Anyway, let's get this started, all right? It's 10 degrees out there on that thermometer. This one over here on the inside is closer to 25, and it feels more or less like 25. So if we come back here to our freezer, we notice that our evaporator's frosted over. Now this type of like real loose, soft sort of frost, it's not like solid ice buildup. Indicates to me that we have a defrost issue, because it's called a defrost control, not a de-ice control. Yeah, we definitely have a defrost issue, whether it's our defrost clock not working, our heater's not working, or perhaps our termination control is failed in the closed position. I'm not sure. So what I'm going to do first, while I still have a load on the evaporator, I don't want to thaw it out right now, because if I thaw it right now, I won't be able to test all the components in the defrost circuit. So what I'm going to do is I'm going to go up on the roof, find the defrost clock, manually engage it in defrost. Actually, you know what, I take that back. First, I'm going to go up there, find the defrost clock, mark where it's at, and see if it's able to spin on its own, just kind of while I locate a few of the components, get my tools up there and whatnot, and then just to see if it is moving under its own power, see if that could be our problem. And then after that, I will engage it in an actual defrost, pull an amp draw on my heaters, check my termination switch, and bring you guys along for the ride. Also, check out my new kicks. Got my new Keens on today. But yeah. Alright guys, here's our condensing unit for the freezer. Looks like old, dried up oil of some sort, but it's all over the place up here. It's heavily stained in oil, right? Condenser's plugged solid. Of course, that's not what would cause our issue. Sight glass looks clear-ish, maybe. Yep, sight glass is clear. There's a little tiny bubble that just floated by. You probably can't see it on camera, but there's a little tiny bubble that just floated by, showing that the liquid level is all the way to the top. Overall, this system has seen some better days, we'll say, right? So this right here is eventually going to just rub through and short out, and there's no nut on the backside. So it appears that whoever rewired this, maybe whoever changed that defrost clock, didn't put the nut back on. So all the wires need to be pulled in order for that to happen. So we got to think about that. And over here, that's just hanging out, but the nut is right there, so I can easily fix that. The one over here, we'll have to see what we find before we get too involved with that. So like I said, right now I marked the defrost clock. It's been about 5 minutes since I marked it. I haven't seen it move yet. I am gonna leave it run for now just to see if the defrost clock moves under its own power as I clean that condenser over there. I am gonna clean it with it running. I'm just gonna brush it off and then blow it out with nitrogen. It's not gonna be a deep clean. It's, you know, it's still kind of cool here right now, so I can get away with not as deep clean. I don't need to get water out. Does it need to be deep clean before the summer? Yes, of course. But right now, with it being, I don't know, 50 degrees out today, I'm not gonna worry about it too much. So yeah, that's where we stand. So let me get some stuff out. We'll clean that real quick. And about 10 or 15 minutes, see if our defrost clock is advanced by itself. And we'll go from there. All right, been about 15 minutes. Got my lunch in. Look at that. That could come in handy. Oh yeah, looks like it would have went right there. So altogether, it's been at least 15, maybe even 20 minutes. Our clock hasn't moved at all. So now I'm just going to manually engage defrost. Then we're going to get an amp draw these elements. If I can do this one-handed. Let's see. We want to go to terminal number 3. Alright, well, our heaters are pulling 6 amps. And for those who don't know, we're still running. It's just pumping down. I assume it's pumping down anyway. Heaters come on. Defrost controller terminates our thermostat circuit. Cuts power to the liquidine solenoid, which is right there. And it just slowly bumps down. So it might take it a while. It's an old compressor. Who knows? Who knows how long it's going to take. There we go. Contactor came off with a bang. But you know what? I can hear that defrost clock just grinding away. Let's see if you guys can hear it. Oh, you guys hear that? Grindy, grindy. Yeah, it's not cool. So I'm going to let that just defrost while I go see if I have one of those clocks in my truck, because we're going to swap that bad boy right out of there. And then, yeah, we'll power it off. See if I can fix this little bit of an issue right there. Fix that little issue right over there so we don't have anything grounding out. And then we'll see if we can't keep this thing up and running for a little while longer. We're still in defrost mode. I mean, we're pulling some amps up at the condenser, but I mean, you see down there it's starting to clear out a little bit, but it's pretty frosted through and through. We could have an issue where only some of the elements are working. So I'm gonna go grab my meter, because we're gonna want to do that before we take the load away, before it completely thaws out, or before I manually defrost it, which is what I'm gonna have to do eventually here. I want to test each one of those heaters individually and see if I can get an amp draw off of all of them. So we'll pull this panel open. Let me see if I can pinpoint exactly which ones those are and check voltages and whatnot. I'm kind of squished over here in a corner, so it's a little bit difficult. Here's my 3-wire switch. defrost termination fan delay switch right here. All right, let me get my meter on this thing. Well, I checked all these defrost heaters, right? Each one of them, there's one, obviously it loops from here, goes back, loops back around, and comes out here essentially. Same with this. So there's one heater here, one heater here, one heater here, and then one that covers the bottom. So there's 1, 2, 3, 4 heaters altogether, right? I verified they're all wired properly. Essentially, one side is going to H1, the other side is going to H2. I have 208 volts across all heaters. I have about 1.4 amps at every single heater. I have verified on the back of the evaporator data tag that the total defrost heat circuit amp draw is 6.9, which is what I was reading up on the roof at the defrost clock. But anyway, these heaters are apparently working, and they are sizzling. So I am going to power it off, and we'll have to manually thaw this thing out, and then we will have to change that defrost clock. And in doing so, I am also going to put that nut back on that whip so we can protect that, because that's our incoming voltage. Just rub it against the chassis like that so we can protect that from rubbing out and causing some damage to something. Yeah, so let's get this thing moving. Cause I got to get some hoses around in here, or a garden hose, and get some hot water spraying on this thing. But right outside that door is the walk-in cooler, and right outside the walk-in cooler door is a mop sink. So I'm pretty close to a hot water source. So I lucked out on that. And I get to sit down on this stack of boxes. Yay. Now I know you guys are smart enough to know this, but anytime you have a situation where you need to manually defrost an evaporator coil, don't just do the back. Also make sure you pull the fan guards if you need to. This time I need to. Pull the fan guards, pull the motors, pull the fan blades, get the front, but also check the side, because right there we got a lot of buildup as well, which, you know, normally when the TXV has that much frost on it, we're looking at a low charge situation, but it's hard to tell because everything is honestly just covered in frost. So we'll have to reevaluate that once we get it cleared. Haven't pulled the fan motors yet. Just kind of gonna do this side, wait till I get bored. And once I'm bored doing this, then I'll put this down, start pulling those fan blades and motors and whatnot. As I've pointed out numerous times in other videos, this little wand, this gardening wand that I got from Lowe's, super helpful in this situation, so highly recommend you pick one up. Got that one all done. I didn't end up pulling the motors, just the blades, because with this little wand here I can easily get into the spaces behind the motor without a problem. Well, up until just this very second, my drain was working properly, so now we are apparently overflowing. So that's a new fun problem. All right, well, I guess I'll have to figure out why we're plugged up now. But like I was saying, I didn't pull the motors. They're easy. You can easily pull them. You just push them back here, and yeah, basically come right out and they unplug, and you're good to go. But I didn't. Just one extra step that I don't need to do because, yeah, like I said, I can just easily get the ice behind there with my fancy wand. All right, well, let me figure out what's going on with this drain now. Here's our drain. Let's see if I can do this one-handed here. Oh, it's so hard. All right. Jam this up in there. There we go. All right, let's get back to thawing the coil. All right, got all the frost off here, front and back, side to side. Real quick, what I figured out is there's a leg of power coming down from the roof that was hot, and it's powering my defrost drain line. I traced it, it goes over there, powers up the defrost drain line, but also it comes over here and then ties into my lights. So I got to kill the light circuit in order to kill all power to the roof so I can put that nut back on the power whip coming in. But real quick, if you guys do this, don't do this. I mean, those wires are just rubbing against there. I'm just going to cut that, zip tie it separately, and kind of separate it from that wire, or separate it from our liquid line so we're not rubbing against it. Possibly going to short out someday. Alright guys, do better. Just do better. So this is what I mean. So I got 2 zip ties on here, so I'm just zip tied so they stay in a nice little bundle. But then the zip tie is essentially zip tied to my what is this, suction header here, and it just keeps it away from the line, keeps it from rubbing out. Simple. All right, let's keep moving. And we're back up on the roof. So I verified all my power is shut down. I can pull these wires, which go to this circuit breaker here. I can pull those through and put a nut on there so it's not just flopping around ready to rub out, right? And then we're going to change this defrost clock to this guy right here. It mounts differently, so I'm going to just take this whole box, screw it inside of there. It's got little knockouts on the bottom that I can run these wire up through. And we should be good to go. Now, one thing that I didn't point out to you guys too is as I was letting the heaters run, I was essentially verifying too that the 3-wire defrost termination fan delay switch wasn't terminating defrost prematurely, which it wasn't. So just in case I didn't get that and you guys are unaware of that. Let's see, defrost termination switch, which would energize our X terminal. Doesn't really show up on here. But yeah, essentially the termination switch just energizes the X terminal and kicks it out of defrost. So if you guys want additional information on that, there's 1,000 million bajillion videos on YouTube that probably explain that a little bit further than I'm going to explain it right now. So also, just to point out, I got that little nut on there, which, by the way, let me show you guys something real quick. If you don't already have one of these, this is a little, I don't know what the hell this is even called, but it's a little nut tool, I guess. I'm just going to call it a nut tool because I like the way that sounds. I like the way that rolls off the tongue. It's a nut tool, but yeah. So essentially, I just use this to tighten those up. Got this at Lowe's. I don't know, like $5 or something, but it's super handy when you get in those tight spots like that. Some situations it doesn't work very well, but most others it does. All right, let's get this tackled. Well, tucked way back in there is the nut that we put back on here, so that isn't flopping all around. Like I said, I got that one down there done. Cleaned up the wiring just a tad. New defrost clock, of course, wired in place. I had to change out some wiring just to make it reach through that body that I installed, this box right here. I got it set for 4 defrosts per day, 45 minutes each. I'm just gonna go downstairs and let's see, make sure these wires aren't loose right here. Yeah, we're gonna go downstairs, make sure my evaporator fan motors come on, and yeah, we'll let it run for a little while, and then I'm just gonna put it in defrost just to double check. But I got to get it cold enough to satisfy my defrost termination switch, my fan delay switch. So we'll let it run for a little bit. Just crank this thing over into defrost. Looks good. I mean, we're pulling 6.2 amps. The data tag on the evap says we should be pulling 6.900 defrost cycles, so we're looking good. I am going to go ahead and tidy this up because it's starting to rain, and I don't want to be out here in the rain because I will melt. All right, guys, we are all set. Box temperature is down to about 15, a little bit over 15 degrees. Like, it's hovering between 15 and 16 degrees when I walked out. So we're all set. Everything looks good. The only thing I didn't do is I didn't hook my gauges up. Now, some people might be asking why I didn't hook my gauges up. And after I cleared all the ice off there, I verified I had a full sight glass. I don't really like attaching my gauges unless I have a specific reason to. And there's lots of nuances to that. Somebody could say, well, I didn't give them a big enough picture diagnosis, but like I said, I know it's cooling. I know it's capable of freezing because it froze the entire coil. And I didn't really see a reason to attach my gauges. Now, hopefully they don't call back with another issue that's somehow related to the refrigerant charge, but in my opinion, everything that I experienced today appeared to simply be caused by the defrost issue that I showed you, which was the defrost clock simply not moving. And then, of course, we tidied up some wiring, re-secured the whip into the box to make sure we had no rub outs, fixed the wiring on the liquid line inside the evaporator coil. But again, I had a full column of liquid in my sight glass. There was an instance where when the evaporator was frosted over before I manually defrosted it, there was a point where I did see some bubbles moving through it. And at one point in time, there was a bubble just kind of sitting in the sight glass. But once I had all the ice off there, once the coil was clear and everything was back up running, I had a full column of liquid in there. And given its age and the overall condition of it, I know if I were to attach my gauges on there and I get out my apps and my wireless probes and I hook everything up, my superheat's not going to be perfect. The pressures might not be perfect. The coil, it was pretty clear, but we're also in the part of the year where it's going to be sort of bypassing. Again, I don't mean to sound like I'm saying like, well, it's not worth it. It's just the main point of this is to explain that I didn't have a reason to hook my gauges up. I didn't see a need to. Everything's cool in the way it should, in my opinion. So until I see otherwise, then I'm not going to hook my gauges up just because. So anyway, we're up and running. Hope you guys got something out of it. Again, good to see you guys again. Hopefully I can do a little bit more or a little more of these when I have something interesting. I haven't had anything really interesting to film lately, but maybe I can get some cool stuff here eventually. So anyway, you guys out there, you stay cool, be safe. If you got anything cool to say, shoot me an email, curioushvac@gmail.com. Love to hear from you guys. Shoot some comments below. Honestly, I don't check the comments. I really don't have time anymore, just with work and everything. But yeah, shoot me an email if you want to, I don't know, chit chat or whatever. Got something, maybe I missed something, you want to educate me, that's fine. I don't claim to know it all. I stay curious every day, man. So yeah, shoot me an email. All right, curioushvacguy@gmail.com. All right, guys, be safe out there. We'll see you soon. All right, guys, remember that walk-in freezer video I did like 2 weeks ago-ish? Well, I'm back. They called this morning and said it's warm again, so we're gonna go check it out and see if we have a possible callback on something I missed or if we have a new issue. It's an older system, but like I said in the previous video, I didn't see a need to hook my gauges up and check the sealed system. Maybe I should have, I don't know, but we're gonna find out, all right? So stay tuned. Yeah, it's definitely noticeably warm in here. Doesn't appear to be a defrost issue. I got $100 saying we're going to be low on charge or something silly. Pull that off. Or we're just not running it at all. That's also a possibility. I don't hear any telltale hissing noises from our TXV, so. The liquid line isn't warm at all. I'll bet you our condenser's not running. All right, let's go check it out. Well, my initial observation is there's nothing going on. If perhaps we were cycling on and off on low pressure, I should at least hear my condensing fan motor run, eh? Compressor's not even warm. Wouldn't it be hilarious if it turns out that somebody just shut the breaker off because they were like doing inventory, or it's truck day or something, and they were just getting chilly? Because today is Monday, which means yesterday was Sunday, right? Let's see, 3 plus 4, carry the 1, 7 minus 2, Tuesday, Wednesday. Yeah, so yesterday was Sunday. And from my experience in the restaurant industry, they normally do inventory on Sundays. So this is going to be super hard to do with one hand. All right, hold on. Looks like we're calling for cooling, right? Let's check our incoming side of our contactor. We got all the right voltages, but our contactor isn't being energized. Let's check our contactor real quick. Alright, I got no control voltage to my contactor. See, compressor contactor. One side is energized by the incoming load because it's a two-way contactor. The other side is apparently controlled by ASC, which is an anti-short cycle device, which is gone. I don't know if it's ever been there, but that's gone. Dual pressure control, so I suspect our dual pressure control. See, now if it was, unless I just have no voltage going to it, but if it were open, I should have, I should be able to have, I should have potential difference, is what I'm trying to say. I should have voltage. Well, I don't have anything to ground, and this one is going directly to my compressor. All right, well, let's take the compressor top off, because also, well, no, I think I need to retract my earlier statement. Our condensing fan motor is well, then, doesn't really show my condensing fan motor, but retract my earlier statement of if we were short cycling on low pressure or something like that, my condensing fan motor would run. I don't know if that's necessarily the case. So some of the other ones, that is the case. This one might not necessarily be the case. But I mean, looking at all this oil, all this residual oil all over everything, like I said before, wouldn't surprise me if we had a leak. But then again, last time I was here, my sight glass was full. So anyway, let's pull that compressor cover, see what we got going on over there. Well, you guys didn't tell me that that is actually my fan cycling control. Right there, cycling my condensing fan motor. All I did was hit my little reset button and it started right up. So we either have a pressure problem or we have a fan cycling problem. Now that we have a compressor running, it's under load, it should be doing something. But we're reading 208 and it should be closed. I should have 0 volts right there. Because we should have enough pressure in the system that it's high enough, or enough high pressure in the system, I guess. The head pressure should be high enough. Let's say that, let's go with that. The head pressure should be high enough that it should close this switch and kick on my condensing fan motor. Unless that switch is bad. So, I'll run downstairs, grab my gauges, and we'll hook up to this thing and see where we're at. Alright, here we go. Got my gauges hooked up. Really nothing to see, nothing to, really to explain. I assume we'll just see our head pressure climb and climb and climb, and then it'll eventually cut out on. Looks like about 450 psi is what it cuts out at. Obviously our head pressure is high enough right now. It should close, but it's not. Feel that needle just vibrating. And real quick, I just want to make sure that my switch isn't closed. All right. Still got voltage across there. The circuit is open because there's a potential difference. I don't want to create any undue stress on this old compressor right now. I'm going to bypass that, and I'm just not even going to leave it in the circuit anymore. We're going to completely get rid of that. Not completely. I'm just going to wire nut this bitch. Some bitch. I'm going to put that in my notes too. That word, S-U-M-B-I-T-C-H. Some bitch. Anyway, I'm going to bypass that. It's supposed to be like 70 degrees out today where I'm at in Michigan. I believe summertime has finally arrived. So I don't really need a fan cycling control as much as I used to. Maybe during the fall. So there's no headmaster on this thing. But I am going to quote to just have this system simply replaced because it's getting about that time. I don't see them really wanting to put a whole lot of money into this anymore. But yeah, we'll see. We'll see. They're doing kind of funky things with remodels and various things. You know, inflation is causing all sorts of different variables for the restaurant industry, I suppose. But yeah, let's bypass that real quick. Put a wire knot on it. And then we'll fire it back up and see what happens. Real quick, let me address a couple things. Yes, I do like to put tape on my wire nuts, only because I'm paranoid about them slowly vibrating and coming loose. Secondly, also moisture intrusion. Could it happen? Maybe. The odds of it happening, slim to none. But it makes me feel better. It makes me feel better inside. Secondly, you might be wondering why I'm not in the Hvac game, why I'm not using Hvac connectors, which, if you're not familiar with those, it's like a little plastic block. It's got 2 little flip-up levers. You just jam the wires in the side, and then you push the lever down, holds them in place. That's like a fancy man's wire nut, right? Well, I have 600 trillion wire nuts in my truck right now, so I'm not just going to jump on the Hvac train yet. I mean, they look nice, they look fancy. It's going to do the same thing as this wire nut's going to do, so why am I going to abandon all the wire nuts, which have served me well over the years, for some Hvac connections? Secondly, you might be wondering why we even need a fan cycle control to begin with, right? Which, by the way, if you know what a Hvac connection is, you probably already know why we need a fan cycling control. So you can fast forward through this part of the video. But essentially, this system doesn't have a headmaster, right? And we want to maintain a certain quality, a certain pressure of liquid going down into our thermal expansion valve in order to feed it properly. And these older systems, I don't know what the exact pressure drop is, but they require a much higher pressure drop than, you know, some of the newer systems, right? And a condensing fan motor cycling switch is, I don't know, what I like to call like a poor man's headmaster control. It's set at a certain pressure that it will obviously turn on when it gets too high, so we don't trip off on high pressure, which is what's going on. But it'll go off in order to let that head pressure build up. Like say in the fall and the winter time, we want a higher head pressure, right? And it's going to be harder to get that higher head pressure with the condensing fan motor running when it's 0 degrees outside, because the condenser is so easily cooled. The high pressure refrigerant, I guess, is so easily condensed when it's 0 degrees out and you have cool air blowing across it, that we need to shut that condensing fan motor off just so we can try to build up enough pressure. And even then, you know, there's no guarantee that just because we shut the condensing fan motor off, we're going to build up the amount of pressure needed to properly feed that thermal expansion valve downstairs. So in the summertime, which is basically summertime right now, it's the you know, a couple days after Easter here, or literally, I take that back, it's literally the day after Easter. It's supposed to be 70 degrees out today. I don't see a need to cycle this fan on and off. Now granted, it still gets kind of cooler at night, so the system won't operate as efficiently as it should, right? Meaning that tonight, when our temperature drops down to say 50-ish, mid-50s maybe, the liquid going into that thermal expansion valve downstairs isn't going to be as high of a pressure as possibly it needs. It'll still feed the thermal expansion valve, it just won't be as efficient. You know, we're going to get a little bit slightly less of a pressure drop across the expansion valve. I mean, is it really going to make a big difference on this system? No, because I mean, there's so many other inefficiencies in this system, so they probably really won't even notice. But the cooling capacity will be slightly lowered, I guess, at night. But all that just to sort of explain what this is for. If that doesn't help, there's a bajillion documents and other videos that properly explain this. Actually, the best explanation I've found is from Dick Wer's book, Commercial Refrigeration for Air Conditioning Technicians. He covers this very well with pictures and descriptions and all sorts of great terminology. But yeah, essentially we just want to make sure we have enough pressure building up to properly feed our thermal expansion valve. And we can't properly feed a thermal expansion valve in the middle of winter with a condensing fan motor running and our liquid being subcooled, our liquid being a much lower pressure than we need it to be. So yeah, that's it in a nutshell. So we got this bypass. Rocking 404 in this guy, so that's about as high as I want to see it. I don't want to see it any higher than that. If you notice, we are bubbling, but last time I was here, I was bubbling as well for a short period of time. So we'll keep an eye on that. It literally just started, so that could be part of the problem. But my head pressure is pretty close to right where I want it to be. I don't want to go just frivolously. Is that a word? Frivolously? I don't want to just add refrigerant just because my sight glass tells me I need to, right? Also, by the way, if you wonder why my needle is just vibrating so terribly, it's because I'm so close to the compressor head. I'm literally just like an inch away from the valve on the compressor, so my needle's going to vibrate. They do make gauges that are liquid filled, where this isn't really an issue. I did try to connect to that earlier, that fitting right there, but the stem on the valve is leaking so badly I couldn't open it without just dumping refrigerant out, which, I don't know, I lost maybe a couple ounces of refrigerant just trying to maybe get it to seal. I backed it out all the way, thought maybe that would help, but it just kept dumping refrigerant, which could be why we have a bubbling sight glass now, but just don't tell the EPA. So anyway, with our hyper vibrating needle, it looks like we're at about a 90, 95 degree condensing temperature. Of course, obviously, it's hard to see because we're vibrating so badly. Could I go get out my digital or my eye manifolds? Yeah, but am I going to? Probably not, because this system is just, I don't know. I look at a system, and a system like this where it has literally so many issues going on with it, just run down and beat up. I'm like, yeah, these gauges are fine enough. There's only a certain amount of fine-tuning you can do on a system like this, in my opinion. In my humble opinion. You know, it is what it is. But all that just to say, my eye manifold probably wouldn't have such terrible fluctuations to it, which we can just go like this and sort of close it down just a little bit, right like that, and see. You just close the valve ever so slightly. Kind of levels it out a bit. I don't know how well you guys can see that, but we have just a little tiny bubble in our sight glass now, and it's slowly going away. As our load and system, I guess, equalizes. Hopefully you guys can see that. Slowly going away, going away, going away, and it's going to be gone in a second. There we go. Don't pay attention to that. It don't work. Not sure why it doesn't work. Our sensing bulb is intact, but looks like we're just a hair below 20 degrees. I think we're up to 30, 35 degrees when I first got here. Now, I'm not using these as a scientific tool of measurement. I had my own probe in here a little bit ago, but I took it out. So just for the sake of this video, I'm going to reference this thermometer. But yeah, my temperature probe is actually about 17, but I had it a little bit closer to the return on the back side of that, but I was closer to 17. But like I said, I already went out and put it in my truck, and I don't want to get it back out again. So that's it for now. It's running. I'm going to tell the manager to keep an eye on it, and hopefully the next time I come here will be to swap this guy out. All right. Thanks for watching, guys. Hey, what's up, gang? So today we have apparently a walk-in freezer to look at again. Just going off of my vague service call notes, my work order notes. The issue apparently is the temperature rising and the display says DEF. So who knows what that could be. I don't know of any word associated with walk-in freezers that starts with the letters DEF. Do you? Because I don't. Maybe defrost? Maybe it's in defrost. I don't know. But anyway, we're going to investigate this issue, see what we can come up with. So I'm going to bring you guys along for the ride. Hopefully it's something cool. If not, then you'll never see this. All right. So we got a 3 evap cooler right here. The other ones down there say they're cooling. This is the one he was concerned about. However, this is the master. Those are all the, what's the politically correct word now? Apprentices, I guess? I don't know. This is the journeyman evaporator. Those are the apprentice evaporators. But if you listen real closely, you can hear that distinctive hiss noise coming from a TXV that doesn't have the correct amount of liquid going to it. So I'm immediately suspect of that, but I'm going to go into this with an open mind. I've done nothing yet. I got to get behind there, just check the evap coils, make sure they're clear, all that stuff. I'll pull this cover. See, there's a code in there, but looks like an A1 code. Temperature's 49 degrees, so I'm sure it's going to be like a high ambient code or something stupid. Actually, let's go right over here. See what it says. Oh, right there. Looks like a high box temperature, so nothing too crazy. So first, let's make sure we got proper airflow, pop that cover open, and then we'll make our way to the roof. And there we have another telltale sign of a underfed expansion valve, which is an electronic expansion valve this time around. So, let's see. Evap doesn't look terrible. Then, taking a peek at the other side, we got lots of green copper. Kind of hard to tell on camera. I assume it's pitted pretty good. I don't see any oil stains though up here, so but it could be leaking out of one of those units. We don't know. I'll pop the covers on those real quick too, and kind of just take a peek at Adam, see if there's any oil stains. Here's our middle evap coil. It's frosted up as well, but right there on the, I guess, the line right before the distributor itself, it's got some oil residue on there. I haven't performed an official leak check, but judging by the sort of remnants of old oil around it, I would say that's pretty suspect. And here's the last evaporator. You can see the distributor's frosted up pretty good. A lot of formicary corrosion on the copper. I don't see any signs of oil, except maybe a little bit around that right there. A little bit on that line going into our distributor. So yeah. If you guys couldn't tell, we're up on the roof now. Just walking around, looking for the condensing units for this place, for these coolers. So just based off of the geographic location of the walk-in cooler, I don't believe either of these two belong to my walk-in cooler, my vault. That's a nice machine. It's kind of neat. I've never seen this model of condenser without a compressor. It's just a straight condenser. The compressor must be downstairs in whatever unit that it is in. Usually this location they have like open air cases, so it's probably some sort of display case. Compressor will be down at the bottom, and of course we got the condenser up top. Same with that unit there. But like I said, I've never seen bone or heat craft units like this, so I walked by and I was like, This shit, man. Somebody stole the compressors out of these. But no, that's not the case at all. So I think over here in our Bone Flex Pack, which I've never seen one of these either, we got a little sticker that says cooler out. And there's only one cooler that I'm aware of, and this would be about right over top of the walk-in cooler and the walk-in freezer areas. So pretty sure this is our guy, which doesn't really fill me full of confidence. See, so I wonder yeah, it's pretty warm. So that condenser, I'm pretty sure it's just dead. So we need a new condenser fan. Coil looks okay. Besides that, I wonder if I can pull this. I wonder if I can pull this access panel without affecting airflow across that condenser as it is. What's funny about this place is anytime I tell them a unit is 8 to 10 years old, they tell me to just replace it. But then I come to some of these locations and I find units like this that are, I don't know exactly how old this unit is, but it seems like it's getting up there in age. Let's see. Nothing on here. I'm not familiar with Heatcraft nomenclature. 2011, I'm guessing, or 2005, but it's probably 2011. Just a guess. So yeah. Well, let me grab my screw gun and see if I can open some panels up. Alright, so apparently I can access the top. Majority of the electronics are up here, or all the electronics are up here. But I'm not real interested in that. I need to get down to the compressor section down below there, see if I can find a sight glass and find the circuit I'm hooking up to. Alright, well, apparently we have two freezers hooked up in this system. Over here is our cooler. Where's it leaking from? Well, I'm 99% sure we have two leaks and two of the evaporators downstairs. But I mean, what are the odds we have any leaks up here, right? So, I mean, again, I could have zero leaks up here. I'm just sort of, what do they call it? Subtle complaining, I guess you will, or being sarcastic maybe. But I mean, look at this awesome piping job. I mean, it works, I guess, whatever. My main areas of concern are this old dried up oil around our receiver, our king valve here. As you can tell, we got some, ooh, it's kind of hot. We got some leak lock right there, leak lock under the cap. This doesn't really give me a whole lot of confidence. The suction dryer back there that's rusted to pieces doesn't give me a whole lot of confidence. Our accumulator, honestly, it's not terrible for an accumulator, but I mean, because they will rust over time. They get wet. Over there on my liquid line dryer, I mean, it's just covered in oil. I mean, it's oil and dust. Yeah, man. I'm gonna see if I can get some eyes on that sight glass from way back right there. I don't really want to take the side panel off, because I take that side panel off, there's nothing to support this electronics shelf. So I don't really want to take that side panel off to gain access to it with the entire unit running, and I can't just go and shut their freezers down, right? So that would be silly to have something accessible. I sort of have access to a liquid line, or the high side of the system, which is going to be a little bit higher than normal because one of my condenser fan motors is locked up. So far, the only suction side port that I see that I would have access to is on the bottom side of that suction dryer. But those are usually just so badly corroded and eroded and rusted. I can never screw onto them properly, and if I do, it's dangerous. I might depress that Schrader core, and it might not undepress. It might not seal itself back up again. I don't like risking that. Right down there is what I'm talking about, man. Right there. That juicy little Schrader core right inside that cap. I don't trust those when they've been on a suction dryer for the last 37 years. Super duper. Let me see if I can get you guys a visual here. A visual aid, if you will. Alright, so I'm going to try to do this one-handed. There you go. If you look in my mirror, you can see I got a lot of flash gas in that sight glass. But we're definitely low on charge in this system. I still don't see an alternate suction port to connect to even recharge it temporarily if I wanted to. I don't remember if there was a suction port at the evap that they use for superheat, a superheat port, if you will. I'll have to go double check. I guess I could charge it from inside the box for now, just as a band-aid. Alright guys, so like I said, upstairs, I don't want to try to pull the suction cap off of that suction dryer and try to charge it up through that, because I don't trust the Schrader core inside that rusty old suction dryer, right? So there's a service test port, or a superheat suction header service port, if you will, that I'm going to connect to, and I'm just going to charge it up through there. It's sort of the down and dirty way to do things. Now, before I get too carried away with it, a quick sort of context to this whole situation. At these locations, I can't just come in and do whatever I want. I have a not to exceed amount of $600. So I need to do what I can temporarily and quote for a big picture diagnosis / repair. So today it's down and dirty. I'm going to gas it up. I'm going to get my pressures up to about 15-20 degree suction saturation temperature, and then I'm just going to double check the sight glass up top and then quote everything that I need to further diagnose in the system, which is, it's going to be substantial, because I like to do things right, and doing things right sometimes costs a little bit extra. So let's start adding some gas, will you? Zeroed out. And again, guys, I'm running it right into the suction header. I really don't feel like there's that much of a risk of accidentally dropping enough liquid into the suction line that it's going to get up to the compressor before boiling off. But again, this is down and dirty. I'm doing what I have to do right now. I mean, we got to keep all these beers and twisted teas cold, right? Alright, let me get this handled. I'll get back to you here in a bit. We're about a little over 2 pounds in, and I just wanted to point out, I don't know if you guys can hear this over top of all the wind noise, but one by one, as I'm slowly charging this, the hissing noise coming from the electronic expansion valves is slowly dissipating. The hissing noise in this unit is pretty much gone. That middle one I don't hear anymore, and it sounds like the one on the far end is still hissing a little bit. But it's just kind of neat. As I'm charging it, I'm almost charging it based on hissing noises. Obviously I'm not. I'm going off of pressures, which I'm just about there. I want it, I mean, if I can get a little bit higher than 15 on the lower side of 20, a 20 degree evaporator, we're maintaining a 35 degree box in here, so. What's up, guys? It's 106 miles to Chicago. I've got a full tank of gas, half a pack of cigarettes. It's dark out, and I'm wearing sunglasses. So you know what that means. That means we got a walk-in freezer that's down, and it's emergency. So let's see what they got going on. All right, follow me. Not sure what all this ice is from, but I'm guessing it came from the freezer. Doesn't look like ice machine ice. Alright guys, not sure exactly what I'm walking into yet. Freezer is almost empty. They're just running low on stock. We got a truckload of stuff coming in about an hour. Manager said they had all that ice in the bag, by the way. That's from this. Apparently there was ice dumping out of the sides here. Just dumping all over everything. So I'm assuming we have a drain problem. It's either plugged, our drain heater failed and it froze up. That drain just looks like garbage anyway. I mean, you can tell there's no real good pitch to it, which is weird because, I mean, we got this right here. Like, we could easily just go right over there. But it's 10 o'clock at night, so this is more or less triage. They have a truck, like I said, coming in 2 hours. They just need this thing up and running. The manager kicked the breaker off because he came in here and he could smell something was hot. And then he touched the bottom of this drain pan and it was hot. And then he pushed up on it. You could hear something sizzle. So he got frightened and he turned the breaker off. But then I got a service call saying that there was sparks shooting out of the fans. Like it's WCW Nitro NWO days. But yeah, there's no sparks or nothing. Right now it's in defrost. So it's pretty warm in here. It'll kick itself out of defrost here any moment now. But I'm going to pull this side open and see if I get an amp draw of our drain heater. And then just visually inspect a couple other things. What is that? What? Wait. Thing is I didn't install this, but I know who did. All right, so yeah, look at it. What is this? What is this nonsense? We got a thermostat right there. Oh, but also we got one right there. What is that one for? That one is our return sensor, and this one is also our something. I'm not sure. That one's set to 10 degrees. This one, not 100% sure. That one might not even be hooked up. I have no idea. Wow, we have two thermostats here. Hey, you guys watching, you want to take a guess before I open this up and try to figure out why we have two thermometers? And like also, who just runs a cord through a chassis like that? Amazing. All right, let's pull this panel open. All right, so this thermostat right back here is not connected, which is weird because, I mean, there's no wires going to it, but somebody took the time to mount the sensing bulb. You know, like this unit, I think was installed, gosh, I don't remember exactly, a couple months ago. But I mean, like, look at this. What is this? 14 gauge, like a power cord that they just hooked up. Like, why not take that thermometer right there and mount it right there? I mean, if that thermometer's failed, just remove it. I don't understand. Do they not remove it because it's hard to get to the screws? That seems silly. So on the list of things that I will be doing, we'll be replacing that. Oh, look at this. Look at that termination switch right there. It's got a little bit of a gap in there. Now, let's see if I can get it to focus right there. Now the gap around it looks pretty even, so it might be like it's supposed to be there. But no, I take that back. The top side, I don't know if you guys can really see that very well, but the top side gap is much smaller than the bottom side gap, if that makes any sense. Sounds like we just came out of defrost. There's our fans a spinning. It scared the poop right out of me there for a second. Let me get an amp draw of our little defrost drain heater. But anyway, back to our, that is our, let's see, that's a 3-wire switch. That's our high limit termination switch, just in case we have a runaway defrost situation. I'm going to quote to replace that just because I don't like that gap. You know, moisture can get in there, it can freeze. Maybe that's what happened, and that's why we have that gap. So there's a little bit of gap too on our 3-wire switch, our defrost termination fan delay switch right there. I can't really get to an angle where I can show you guys. Maybe over here. Yeah, not really, no. But around the black part of that, where it just goes into the metal part, there's a bit of a gap in there as well. So I'll probably add that to my quote of things to do. But more than anything, I need to address that drain situation. It's not something I'm going to be doing at 11 o'clock at night. We're going to remove that thermostat, cut out that drain. Even that drain pan heater is kind of bent up on that one side, but I mean, honestly, it's not the worst thing in the world. I don't like that heater. I'm going to change that heater. This little in the line heater, I don't like that. You know, looking at this drain pan too, it almost looks, I don't know if I can get that to come across on camera too, but it almost looks like when they put that drain in, like they pushed up on the center part, because like the water that is defrosted is just pooling up in the center, and then our drain is back there. Like, again, I wish I could get this to come across better on camera, but see, like right there, you see that little cord, the steel braided line way back towards the middle? That's our heater. Let's see if I can get it like that. And then we have all this water pooling up because that drain is sitting higher than our heater. So that'll be redone, and I'm gonna put a better heater in there. I'm gonna wrap it in heat tape and then re-insulate it, of course, with some better insulation than that shit. Yeah, so that's it for here. I'm gonna go upstairs and see what we need to address, if anything, up at the condenser. But I'm starting to see my breath, so I think that's a good sign. Kind of a crappy angle, I know, but there's our amp draw on our condensate drain line heater. We have no amperages. I don't know if we have voltage there yet. I haven't checked, but I'm pretty sure that drain line heater isn't OEM, so is an aftermarket piece installed, so it might not even be wired properly. I got to see where this thing's wired to, and it might not even be wired for constant power. They probably just tied it into the heat circuit, so it only warms up when it's in defrost, which is obviously stupid because you want it warm all the time, right? Am I right or am I wrong? What do you guys think? All right, let me track some voltage on this thing. Yeah, so this drain line heater, guys, it goes to terminal 4 and terminal 3. So if you come over here, we look on our fancy little wiring diagram here. 3, let me set this down so I can point. I need one of those little hands like T.Y. Banana Man has. Ty Banana Man? I don't know. So anyway, yeah. So 3 right here comes from our defrost clock and energizes this side of our heaters, right? Comes over here, jumps through this, goes through our heater safety switch, yada, yada, yada. And it goes out our, not out our neutral, it's a 2-way heater, so it comes in this side, comes in this side. And then the other side of that drain line heater is attached to number 4. Number 4 is our thermostat circuit, or what I call our thermostat circuit, which will energize our liquid line solenoid. Although it shows right here on this. But let me double check something real quick. I'm just gonna think out loud during this entire process. So there's our SOG cord, comes from R, goes down, wires into that. That goes to neutral, and so it is tied into the neutral. So I wonder how that directly controls our liquid line solenoid. Let's see, that's number 4. I think this black wire right here goes to our liquid line solenoid, I believe. Yeah, just ignore that relay. I believe that's a fan delay relay, or not a fan delay relay, but it's a fan relay of some sort. It is unplugged, yes. I can't remember exactly why those are unplugged, but I remember there being a reason, so I'm not overly concerned with that right now. Man, that thermostat just looks so stupid. So I'll have to take care of that when I come back. I'm also going to clean up as much of this wiring as I can when I come back, and do everything on non-emergency work. Anyway, back to this. So it looks like they're powering that condensate drain line heater from the heater circuit, because one side of that heater goes to 3, the other side goes to 4. Now, the side number 4 at our defrost clock is, like I said, is the thermostat circuit. So, actually, you know what? So let's think about this. I'm going to think out loud here and risk sounding like an idiot, right? So at our defrost clock, when we're in defrost, our little timers align and our switches move, and our number 3 terminal is energized, right? We've all seen it. Number 3 is energized for defrost, and number 4 on our defrost clock is energized for the thermostat cycle, which is energizing our fan. So if I have a heater going across here, when would both of these terminals, assuming that's a 208 volt heater, when would both of these terminals be energized to give it 208? Am I missing something here? I mean, if all these fans are 208, I guess we could back feed through the fans, like, is that, let me double check something. Am I on 4 or am I on H4? No, I'm on 4. I'm not on H4. Maybe it's just too late in the day, but yeah, I'm definitely on 4 and 3 right there. That's my condensate drain line heater. So, alright, so that doesn't appear to be a true neutral. It does have voltage going to it. I was getting 208 across these two. Was it these two or these two? I think it was these 2 terminals. I apologize, guys. It's late. I'm tired. So I may misspeak from time to time. Yeah, all that to say, our drain line heater isn't wired in a way where it's going to be on continuously. It is only on, apparently, during the defrost cycle. But the thing I'm trying to figure out is if I'm wired into 3 and 4, I don't even think it's on then. But I mean, it's got to be on at some point in time, right? Because if it's only wired in 3 and 4, terminal number 4 is only energized when I'm in cooling mode, and terminal number 3 is only energized when I'm in heat mode. Let's go over here and see, just to satisfy my curiosity, what kind of voltage we have right now across 3 and 4. There's 3 and 4. At 208. Oh, maybe I'm wrong. I got 208 across 3 and 4 right now. And I don't really have any amp draw. Kind of confused by that. I'm not gonna lie. The condenser. Sight glass is clear. Running 404. Huh. What is that? Are you serious with that nonsensical bullshit? Well, I take that back. I can't call it nonsensical bullshit. It may have been installed, you know, at an emergency. Sometimes, when we go out and we do service calls, and later on we quote for expensive repairs, they don't want to do the expensive repairs because, in their minds, well, the system's up and running. And yeah, it's up and running, but it's an emergency. Now, that's just a, what do they call it, like a Schrader depressing valve or something like that. Which, I mean, it's clever on the fly. It gets the job done. We got a pressure switch in place, but it's not ideal, I guess. It'll work. I mean, I'll note it, and I can't imagine they're going to give me approval to shut the whole system down, pump everything down, and pump it out of the system and valve it off right here, and then put it on properly. But we'll see. Anyway. Nothing too crazy up here. They got a train. Wait, we got a train. Is that a York? We got a train, a York, and a Lennox. What is this, the zoo? Look at that. They're like, let's get a Lennox. No, let's get a train. Then the one guy's like, no, let's get a York. Those two look awfully similar, right? That's pretty old. This is pretty new. I don't remember this being here previously. That drain's gonna work real good. That drain reminds me of that old nursery rhyme when we were kids. There was a man from somewhere, had a crooked back, crooked neck, or something like that. Wait a minute, am I thinking the other one? There was a man from Nantucket. Had a... Never mind. I don't know, I'm tired. Dun dun dun. What's up, train? You suck. Got a nice... I guess it's kind of trapped. It's like the bare minimum of a trap right there. But it is technically trapped, so... Anyway, guys, I'm going to make my way out of here. I'm going to let the area manager know they're good to go for tonight. I'm going to come back, hack that drain off, see if I can kind of bend that drain pan out a little bit more, reform it, because like I said, it looks like it's been pushed up to make that drain fit. Then we'll redo that drain, get a better slope on it, better heater in place, and yeah, we'll go from there. Oh, I'm also going to quote to replace the whatchamacallit, the high limit and the 3-wire switch on this guy. I don't think they're failing at all, because we don't seem to have any sort of defrost issues or early termination issues going on with this system. But I don't like the gap that's in the body of those. It doesn't look even. It doesn't look like it's meant to be there. So when in doubt, change it out, right? And then I'm also going to remove that spare thermostat that's up in there, and then I'll make a note of this valve or this Schrader core depressing valve that's on there. Yeah, we'll make a note of it. See if they want me to address it or not. They probably won't, but hey, I'll bring it to their attention, and if they don't, well, that's on them. All right, guys, have a good night. I will see you soon. See, auto mode, heat on, second stage, fan, 67. All right, I'm gonna go check your roof. So apparently we don't have heat in the dining room section of this location. Here's our rooftop unit. It's got model numbers and such. I don't know what any of this gibberish means. 102, 18. There's no telling what size this rooftop unit is. It could be a 100-ton rooftop unit for all I know. No, I'm sure it's not any bigger than a 10. I can't remember York nomenclature, what 102 means. Huh. Alright. Well, anyway, let's get started. Let's check for power first. How about that? Let's do a quick little visual of this guy. It's probably 40 degrees out, maybe 45 degrees out today. I hear a blower. That's a good sign. Got a contactor pulled in. I'm going to assume that's our blower contactor. What's this? Limit switch locked. Nobody cares about mixed air temperature, blah, blah, blah. Economizers only belong in California. Come on, fan only. Where was it? Number 4, something about limit switch. I'm gonna guess it means high limit switch is tripped. Number 1, locked out due to what? High pressure. Interesting. So we have a couple of things going on apparently. Heat stage 1 locked out. That's the one I'm looking for right now due to limit switch. Alright, that's what I thought. But apparently we also have issues with its cooling as well. This is a location that doesn't believe in preventative maintenance, so that's probably part of the cause right there. The front of the coil doesn't look bad. I mean, honestly, I can see through it. So even though the backside is bad, it shouldn't have been that bad to kick off both compressors. Let's climb up here. I mean, doesn't look like they're physically seized, but who's to say? Now this system is automatic, what do they call it? Automatic changeover. So what I'm going to do is I'm going to bypass the thermostat up here with a jumper, because I can't crank it up downstairs because it's a thermostat that's controlled by a remote company, an energy management company. So I don't have the ability to change anything at the thermostat. I also noticed that's tapped wrong. Guarantee we have 208 coming in, not 230. So what I'm going to do is I'm going to heat that dining room up to like 75 or something. And then, assuming that the heat will work once I play with the high limit switch. And then it'll be warm enough that it'll just automatically change over to air conditioning, and I can also double check the air conditioning while I'm here. Alright, let's see. Fiddle with my hands, fiddle with my hands. 213. 213. Alright, so we know when we do, I'm not going to power down right now because I want those codes there for now. We do know that when we power it down, we're going to have to retap that transformer. No big deal. Go. That looks like a normal operating heartbeat mode. See our rollout switch. There's our high limit right there. Nice and rusty, of course. Alright guys, I'm gonna have to get two hands on that. Let me put the phone down real quick so I can just, all I'm gonna do is check across that high limit switch back there for continuity, see if it's open or closed. Don't worry, I'll bring you back in just a few minutes. There's our little limit switch. Ends of it are really corroded, so I'm just going to go right down here to the back side of it. I'm going to drop my meter lead into the water because that's what I wanted to do. It's not toning out, just so you guys can tell. We got nothing. Yep, I got nothing. Alright, so our high limit's bad. So what I'm going to do is I'm going to put that back on here, and I'm going to jump out the high limit just for diagnostic purposes, because I want to make sure everything else in this circuit works fine. I want to make sure we're able to ignite. I want to make sure our inducer works fine, pressure switch, ignition control, like everything. I want to make sure everything else works fine before I go ahead and just replace this little deal. So let me hook this up real quick. I just got a double-headed spade connector on there. We'll run this in a second, but of course we're gonna check everything else. Belt looks pretty good, I suppose. No wild cracks in there. Pulley definitely has some signs of wear. Not real terrible. No rough edges, but you can definitely tell the V shape in the pulley. That's normally pretty pronounced. That V shape it's worn down quite a bit, so that pulley should definitely be replaced. This is a sort of a nickel and dime customer at times, and they might not want to pay for that, but I still quote it. So we'll do a drive pulley. We got a spare belt. I'm gonna get another spare belt in there just because. What do we got? Is this the same size belt? A54. Yeah, we got the same size belt. Let's see. Blower wheel doesn't look terrible. Check our heat exchanger. All right, no areas of concern. Also, I retap the transformer. There may be a delay due to that thermostat, I believe. Or actually, there's a delay right there. All right, well, I will bring you back in about 109 seconds. How about that? All right, we are heating. Kind of hard to see back there, but we're definitely heating. So I changed my mind. I don't want to heat. Well, no, I take that back. I'm going to let it run for a little while I investigate. I got to figure out how to clear the codes out of our control board there. So we're going to let that warm up, make some phone calls, see if I can find a high limit switch anywhere. And yeah, we'll go from there. So I was just exploring the wiring diagram here, so I wanted to make sure the M4 right there is our outdoor condensing coil or condensing fan motor contactor, right? Which is right there, the little guy all the way to the left. So that's the coil right there. I just wanted to make sure that it's not controlled by any sort of high pressure switch, meaning that the high pressure switch, or there's a pressure switch somewhere in there that would have to close in order for those to come on. Almost like a fan cycling switch, basically is what I'm trying to say. And there doesn't appear to be anything like that. So then we come down to blah, blah, blah right there, M4. So assuming it closes, we should have full power to that fan circuit. Now I'll come over here, and I already got these open. I've already looked inside here, but just for the sake of YouTube's algorithm, I'm going to pretend that I haven't and be surprised. Like, oh my goodness, look what I found, a broken wire. Like, oh man, oh my, wow, I'm so surprised. Yeah, I just saw that. So what I'm going to do is pull down a little extra wire out of that bundle, clip on a new spade, and actually I'll just verify that. I mean, I'm sure it's closed because it's cold out and the system isn't running in AC mode right now. And maybe we'll get lucky and that's the only problem. Of course, I still have to clean that condensing coil, but not today though. That'll be another day. And this is a customer that uses a NTE amount, and all of you guys out there that don't know what that is, that's a not to exceed amount. So for example, on my work order, the NTE amount is $500, meaning I have up to $500 to come out here, do what I need to do to diagnose, possibly repair, if the repair falls into that NTE amount. I haven't gotten a hold of any York suppliers in my area. The only one that I'm familiar with is about an hour away. So chances are that not to exceed amount isn't going to be sufficient enough for me to travel to get this switch that I need and come back. So we're going to probably quote this. I know how that sounds. It sounds real stupid. I get it. I don't make the rules. Don't hate the player, hate the game. You know what I'm saying? That's just what it is. I gotta quote simple stuff like this that could easily be fixed, but it is what it is. So let me fix that spade, and yeah, we'll get back after it. You know, another thing I noticed, I'm sure you guys already spotted this because you guys are smart. These filters, like, they stick out so far that whoever changed the filters on here had to pull out these filter covers. Now I get it, with these doors closed, you know, this door and the control panel door over there, with those closed, it's really not gonna affect much. But when I'm standing here servicing it in the middle of the summer or in the middle of winter, it's gonna have some effects on how it operates while I'm trying to diagnose it. So I'm like, why not just go back with the right filters, you know? I just assumed that they either got the wrong size filters or this is just what they had on the shelf. It was like, we'll take it. What do you got? We'll take it, you know? Oh well. They have a separate company come out and do filters. That's the only sort of preventative maintenance they do, I guess, is just filters. So anyway, I will notate that in my notes. Here we go, guys. Buckle up, get your coffee, put your headphones on, and let's roll. And we say goodbye to Michigan and welcome to Ohio. It's kind of ironic as I follow what appears to be an Ohio school bus. I'm following that across the border. Also, don't mind all the bug guts on my windshield. I try to swerve to avoid them, but it turns out I don't have the reaction time. I can't do it. I can't do it. I end up running a lot of cars off the road. Almost there, guys. So guys, I still don't have a call for cooling on this unit. I went downstairs. It's because the thermostat's satisfied. So we are going to create our own call for cooling. Just gonna bypass that. And yeah, see what happens. I was just about to throw a jumper on there and it kicked into AC mode. Let's see if I can get any of this to come across on camera. My screen is up as bright as it can be, I guess. So, not sure if you guys are going to be able to see any of this, but we are at 152 on my low side, 315 on my high side, slowly dropping. Our ambient temperature is 82 right now, so I'm probably going to get a condensing temperature of, 100 and, what are we running here, a 410? 102, maybe 110, I guess. I'm not 100% sure, but I think these newer train units are running at 25 degree above ambient condensing temperature. Our evaporator temperatures still dropping. We're down to 51 degrees. Suction saturation temperature, rather. And that's saying 115 degrees. Which is not correct. See, blower isn't engaged. I'm gonna have to pull that panel off, make sure our blower is actually blowing. I'll give it a second because it literally just kicked on, so. But our temperature inside this supply plenum should be dropping much faster. I mean, we're just slowly dropping. That's weird. Yeah, that's my return over there. This is my supply, so I'm on the right side. Panel isn't open or nothing crazy like that. But we're still hovering like around 110 degrees supply temperature. Awesome. All right, let me pull that panel open real quick, guys. Hold on a second. Now, if you guys can see this, but according to my scientific tools of measurement, it's 172 degrees in my supply plenum. Doesn't make any sense. I mean, I feel like what's happening is there's a layer of insulation that I'm just pushing forward instead of stabbing through. You know what I'm saying? Like, so this is my secondary, my backup one. And I feel like there's I don't know, I can feel like some sort of resistance, but I'm not popping through it. So I'm gonna pull that bottom panel off. Shut this unit down real quick, pull that bottom panel off and see what we got. Something funky's going on. I totally forgot we got heat strips in this thing. I haven't checked the wiring yet, but I would guarantee as soon as I power this thing on, I'm going to be getting heat strip action, and that's why my supply plenum is so hot. I just heard the heat strip contactor pulling. Yeah, right there. Our heat strips are on right now. I mean, do we actually have a call for heat? You know, come to think of it, I don't even have any wires on my W1. How do, what are we on, orange, ground? How do my heat strips know when to come out? First, let's see if we have something on Y1. I don't have anything on Y1. So why am I heating right now? Alright, let me dive into this a little bit, because obviously I shouldn't be heating right now. I'm going to try to do this with one hand. I am legitimately calling for cooling for some reason, or heat rather. So my heat strips are on right now. It's 80 degrees outside. In the defense of this unit though, and I'm going off on high limit. That's that clicking noise you heard, that's my contactor just shutting off because I'm cycling on and off on high limit. I mean, we don't have an economizer on here, of course. But why? It can't be that. And I haven't been downstairs yet. It literally can't be that cold downstairs. So, let's go downstairs and check it out then. First stage, let's go double check, but we should be in cooling up on the roof. Walking, and we're walking over here. And we are in cooling mode, so the hell, man. I take that back, see? Our heat strips did just kick on. Why are my heat strips coming on? I knew they were, I wasn't crazy. See? Right there. What the fuck's going on here? Pardon my French. What the F is going on here? Why are they cycling on and off? I'm going to test across my high limit. Let me put this down real quick, guys. So right here, I sort of isolated everything, a little bit anyway. Here's my W1 coming from my thermostat downstairs. And we're just going to check a couple things real quick. I want to make sure I do have, so I got 24 volts. I don't know how well you guys can see that, 'cause it's bright out here. I can't see my camera, so anyway, we got 24 volts on my Y1, which is what I want. But then also, let's see if I can do this so you guys can see it too. Come on, meter. There we go. All right, let's do this again real quick. 24 volts Y1, right? And we got, let's check this guy out. All right, you watching? Pay attention now. 24 volts on W1 as well. Hold on. I'm sure you guys saw it, but there. See? So our thermostat is apparently calling for heating and cooling at the same time, which is ridiculous. So I'm going to change that thermostat. I replaced the thermostat, guys. I verified I no longer have a call for heat on my W1 terminal. Our supply temperature is now, I don't know if you guys can see this. It's so bright out here. There we go, 52. Supply temperature is now 52. And I'm just sort of monitoring my operational pressures, my operating pressures. The evaporator temperature right now is 41 degrees, 41.2, rising. It's kind of flopping around a little bit. And my condensing temperature is 96 degrees. So we're doing pretty good. I'm gonna creep around here for a bit, get some water, and just kind of monitor it, see if anything crazy happens. Alright guys, we're all set here for today. That unit's up and running. This unit right here with the Bastion coils up and running. It's hot out, I'm thirsty, so I'm gonna get out of here. Alright? We'll see you guys on the next one. Alright guys, walk-in freezer, 11 degrees. Let's get into it. There's the floor. Feels pretty cold in here. I can see my breath. Uh-oh. A little bit of ice right there. What's that from? Well, our drain pan's not blocked up. I wonder where that ice came from. You'll notice there's some up on the top as well. Heater does feel warm. There's nothing in the bottom, so the drain pan's not full. So that's cool. Alright, let's get into it. Alright guys, I don't know if this is coming across on camera very well due to the spinning fan and whatnot, but the evaporator coil seems to be heavily frosted on the top half of the coil there. I'll stop the fans eventually and maybe get a better view of it, but it essentially matches the back of the coil, so possibly a defrost issue, but seems to be more or less isolated to the top of the coil than the entirety of the coil, which is weird. So I want to pop that side panel off and just get eyes on the expansion valve real quick. See if that's all frosted up or whatnot. And it looks like not the expansion valve itself, but the distribution tubes, or the distributor, and whatever else is in there, suction header, liquid header. Yeah, that's all a block of ice. So possibly a low charge, which would cause the refrigerant to flash off right outside of the expansion valve and the distributor, and it would start absorbing heat there, frosting up. The defrost heaters wouldn't be able to affect that, so that's why we get that block of ice forming. And if it's undercharged, it's not feeding properly. The evaporator's not feeding properly, so that could explain the top part of the evaporator being frozen up, but not any other parts. So yeah, the other thing is, like, it's really, really cold in here. So if we were undercharged, I feel like it would be warmer. I know it's like 9 degrees in here, but still. I got a temperature probe sitting over there because it just feels really cold in here. So my probe says about 7 degrees. So I think it's time we make our way up to the rooftop and just take a peek at the sight glass and see what that thing looks like. And then we'll manually thaw this, and then we'll have to gauge up to it and see what we're dealing with. Real quick before we go upstairs, I want to check our thermostat. So right now we are open. It's 3.5 degrees. So it's set to just a hair above zero, so our thermostat's nice and accurate. We're down to 3 degrees. I mean, mechanically, this thing is able to cool this room down the way it should. Not real sure why we have that much ice on there, though. Did notice this. Like, that's not super cool. Seems to be all over the top of the box. It's not sealed very well, not at all. Like, look at that. I know you can't see that, but ceiling panel is concave. Like it's real bad. I wish there was a way to show you that. And again, I don't know if that would affect it. Obviously, it's not good to have that much moisture coming through the walls like that. Obviously, it's not sealing as best as it can. That was our thermostat kicking back on, our solenoid opening back up, and we're back into cool mode because we're at 7 degrees. But anyway, I'm going to hop upstairs, take a quick peek at the condenser, and then we'll start thawing this guy. Alright, just got up here to our condenser. Suction line's a little frosty. It just pumped down and shut off, like right as I was walking up to it. And I'm pretty sure it's because the thermostat is satisfied at 3 degrees, so it doesn't seem to be a problem with it cooling. There is a large oil stain right there. I mean, a system this old, it's hard to say. That oil stain could have been there for the last 7 years, who knows. I'm just going to wait for it to kick back on. We'll check the sight glass. I can hear the defrost timer running. We'll pop this open and get some eyes on that, make sure it's actually turning. I mean, I can hear it. So my instinct is that it is. Jeez, bro. Alright, you guys notice where that's at? Right before the 4. We're going to let that run and then see where it's at in a few minutes. Actually, it's better if you put a little mark on it so you don't forget. See, just like that. And then also what you want to do is put it through a defrost. Make sure it can actually get itself out of defrost. And if you have any doubt that that defrost timer isn't working, just change it. I mean, if it seems like it's spinning kind of tight, if it's making a loud noise like that one, I mean, it seems kind of loud. I don't know if you guys can hear that, but it seems kind of loud. In contact, it looks old-ish. I mean, nothing too crazy, nothing out of the ordinary for a system this old, so. Alright, our system just kicked back on. Sight glass appears to be nice and full. Didn't feel a whole lot of heat coming off of that. Condenser appears to be clean. Let's see if both fans are working. I assume they both are, but yeah, both fans are operational. Yeah. Alright, well, I'm going to give this thing a few minutes just so I can check the defrost timer. And then I'll power it down. We'll go down. We'll thaw the evaporator manually. And yeah, pop some gauges on here and see where we're at. Bust out my eye manifold. Get some superheats, some subcoolings. Just walking around this rooftop here, getting my steps in, and I noticed this squishy part right here. Squish, squish, squish. Right around where this line set goes through the roof, so it's probably a leak or something. Moisture got under this roof, rotted the wood. Not sure. I mean, it's an old roof, so anything's possible, and that could be the reason why we're getting moisture around or in the seams of that walk-in freezer box. And once that moisture freezes, it starts to push the seams apart. So that could be what's going on. One of the things I'll be doing is getting up above that walk-in freezer box and kind of checking out the top panel, the ceiling of it, if I can, if there's access to it, just to see if anything's obvious. But anyway, while I got you on the line, Does appear our defrost clock is progressing. So let's crank this thing over and defrost. It spins pretty freely. It's pumping down. Grab our meter. We'll get a and we are mostly defrosted at this point. I gotta pull the fan covers, fan blades, and we'll hit the front of the evap real quick, but just a quick shot of what it looks like right now. One thing I noticed as I was standing back here too, this seam, I don't know if the camera's doing it any justice, but it's sort of like split and pushing down right there in the middle. Like if you can see, like you notice, oh man, I'm falling down over here. So if you'll notice, there's a gap right here. So right there, that seam, it's like pushing down. So it's kind of like bowing, not really bowing the evaporator, but that's why there's that gap right there. It's really weird. There's just a lot of moisture in this box and these walls and everything. It's not good. Not ideal. Actually, once you get the fan blade off, you can see it's much worse. We got all sorts of snow in there. Why? Not real sure yet. So, well, let's get after it. All right, here we are up in the ceiling, and right on the other side of this wall are our walk-in freezer and walk-in cooler boxes. But I don't have access to them. Well, it took a little bit of doing, but I got up here. So right over there, that's the front of the box where that wall was. I just came in through a ceiling tile on the side of the box. So let's go for a little walk. See, again, I don't know if you guys can see this, but it's just rippled and concaved. There's not as much water damage as I expected. I mean, yeah, there's definitely some, especially right around there. You can see where it's kind of been pooling up a little bit. Now they have these drain pans. I can only assume that they knew there was a leak, and that's why these drain pans are here. Try to walk on the seams, make sure I don't fall through. Yeah, look at that. There's that soft spot. Look at that. That's awesome. Actually, no, I take that back. The soft spot I was feeling was right over here, next or near our, was it? I can't remember now. I'm pretty sure it was over here, like right in the middle of this. Oh, probably right there, where all that rotten wood is. Interesting. Well, I'm going to get some pictures of this and send it over to the proper authorities. See, guys, this is why you got to be careful when you're walking on roofs. Let's see if we can get over here. Like, look at that. Yeah, it's shot, bro. Very nice. I'm gonna go upstairs and dance around and get a good lawyer on the phone first. All right, let's get back to work. I just cranked the system back on. We got our eye manifold connected. So We'll give this a little while to equalize, kind of get up and running, catch its wind, if you will. And yeah, we'll see where this takes us. Just packing up here, guys. Getting ready to go downstairs, check the walk-in box temperature for the final time. Yeah, so I ended up with about a negative 15 degree evaporator, and my condensing temperature was, what was it? I know our head pressure was 194, so that gave me a condensing temperature about 86 degrees. And today's kind of cooler out, so that's absolutely 100,000% all right. Superheat was a little bit high. It was creeping up around 40, but again, it's a couple of things. A couple of things contribute to that. One being that, as far as I remember, a majority of these older manufacturers, at the compressor, it's not crazy to see 20 to 30 degrees of superheat, right? Couple that with the fact that my 18 to 20 foot long suction line is poorly insulated, which again, I'll be addressing in a quote, along with the roof issue, the seams, the gaps in the wall panels, a couple other things, a broken fan bracket that I found. But anyway, our suction line is poorly insulated all the way down, all the way into the box, so that's going to contribute to a little bit of that. Plus, you really only want to measure superheat when you're within 5 degrees of your temperature set point. And I had the box off for quite some time. I hit the evaporator with a bunch of hot water, so when I was taking my measurements, I wasn't real close to it. But I will say this without going into too deep of a rant. On a system like this, yes, I do want to give the full big picture, right? As my buddy Chris Stevens always says, I'm giving them the full big picture, but at the same time, yeah, I got to keep it real. I mean, this is an old system. I'm not going to get, peak performance numbers out of this, right? I'm not going to get, the day this was manufactured, I'm sure it ran a little bit smoother, a little bit more efficient. I'm not going to get those numbers out of it. And so it is what it is. But within reason, I should have good operational numbers, if that makes any sense. Within tolerance, there's a certain tolerance that I allow, or that any machine should allow based on its years, its abuse, its physical condition, all that stuff. But all that just to say, I'm going to go check the box. I'm going to get out of here. All right. Hey, what's up, YouTube? So today, we got an extra special one. We got this guy right here, not cooling, right? It's old, I know. It's quite beat up, I know. You guys hear that?
Set up the time.
I know our AC's not running, but
Show up 2 minutes before you start.
it sounds like talking. I hear talking. I hear talking coming from the side. It's like a speaker, maybe something going up from the restaurant. Yeah, it's weird. It's definitely
I show up typically an hour before the show.
radio or a phone or something. There's some sort of noise in here, guys, and it's not a compressor. Let's pull this cover off, see what's going on. A little bit louder. A little bit louder now. Man, that unit looks like straight trash, but do you guys hear that? It's like
You're listening to the most downloaded HVAC entertainment podcast in the world. Welcome to the HVAC Overtime Show.
glory hole. Oh, you guys see that?
What is in
And I was
It's
messaging
the
back and
HVAC
forth with you guys
Overtime
talking
Show.
about my stretchy pants, and I was like, I have the best stretch
Hosted
pants
by
in the
me,
world, so I just straight
Bill Russell,
dropped my pants wherever
my
I was
buddy
at,
Adam
and
Muffich,
took a
my
picture of the
best
label.
friend
I was
in the
like,
whole
what
world,
are you doing?
Chris
I'm like,
what you're
Stefanovic,
trying to do.
Bill
and
wanted
my
to know what
Canadian
kind of pants
amigo,
I had or something,
Joe-
and then she's my wife's like,
Joe
why are you-
somebody. Look at that shit.
I hope your wife's
That's
seen that
awesome.
thumbnail then.
I think I did.
I didn't know Carrier
Actually, I
was
did, yeah.
going with this model.
Dude, me and my wife
control
share
board.
everything. There is no super secret anything. I share everything.
Super gay. You and your wife
Let's
are
tune in
super
for a bit.
gay.
Yep.
Like
It's not even
ambiguously
Friday
gay
at 9
duo,
o'clock when they
except
normally
it's
go
not a
live.
Little boy.
Well, now, who would have guessed that Carrier has apparently changed over their control board, so whenever it goes into default, it just automatically plays the HVAC Overtime Show in this little glory hole. Way to go, Carrier. We'll see you guys Friday at 9. So apparently this thing's not cooling. Starting to get some cottonwood built up on there. They have another company, a maintenance company that comes out here and does all their cleaning, changes their filters, blah blah blah, which would explain why these metal mesh screen filters are gone. So make note of that, but like I said, we don't do anything with that apparently. So visually, I mean, I can hear a condensing fan motor running. At least one, maybe two, I don't know. Alright, feels like they're both running. Let's see if our blower's moving. Blower's not doing nothing. That's cool. Let's see if we got anything going on in here. Nothing going on in here. That's not good. We just keep plugging along here. Let's see. Nothing going on in this circuit. Feels hot to the touch. Like feels like it's been running. Just very, very hot. It says it's cooling. Let's see if there's any error codes. History. Whoops, I want data. There we go. So data. Let's go with history. Alarms. Waiting. Wait. Com failure. Let's see, outdoor temperature sensor. That's that common on all these. That seems to be it. So nothing to lead me in any direction. Let's see, that looks, I mean, I don't see any obvious oil stains. I mean, I was looking to see if maybe we would be off on low pressure. Ooh. I missed it. One of these guys was just trying to run. I'm assuming it would have been compressor number 1, which is B1, which would have been that back guy there. So let's get this thing out here. Why is our front compressor not running though? Let's see if we're in we're doing a call for single stage or 2 stages. Alright, there's our single stage, or our first stage rather. Yeah, so we're calling for 2 stages of cooling. double check. It's going to take a second for that to reset anyway, so let's oh, look at that. All three compressor contactors, well, excuse me, all three contactors are pulled in. Two of them are our compressors and one is our blower motor. And our blower motor wasn't moving. I have a feeling we don't have enough power. I don't know if you guys can see that, but we're only measuring 89 volts, 208 right there, 125. So yeah, we're missing some voltages. Let's power this guy down before we do any damage, any further damage to this thing. Well, we're now looking at a fused disconnect, so let's pull that and we'll check incoming voltage at our disconnect. So immediately, again, I don't know if this is coming across on camera very well, but I can immediately tell that far right leg is having some issues because it's charred, partially melted. I assume that that disconnect has gone bad. So I'm going to check for voltage right there. And if I do have proper voltage, I'm going to go downstairs and I'll just shut it off at the breaker. And we'll end up bypassing this disconnect for now until a new one can be ordered. Alright, I do have it back on just so I can measure voltage going out. 208, 208, 208. So we have correct voltage going in. 208, 208. So we do have correct voltage now. It's probably because I turned it off and turned it back on. Not even really measuring a voltage drop across there. Let's go back to our compressor that I checked. Eight, 208. All right, so I inadvertently, I don't want to say fix the problem, but by re-snapping those contact points inside that disconnect, I just gave it a better connection, which it will eventually fail again once it gets real hot out. So I'm still going to bypass it. They still need to replace that. So let's go get some big wire nuts. We'll power that off at the breaker and we'll bypass that and order a new one. Disconnect has been removed and also bypassed. I see it right there. You can see it's melted. It's failed. Should no longer be in the circuit. I might pull that thing apart just to look at it. Yeah, we're all nice and tight and secure. I kind of went a little overboard on zip ties and securing it because I honestly don't know if they're going to approve anything. Once they see that it's working, they just might say, yeah, whatever. And then also, I wrote on the interior that the disconnect has failed, turn off at the breaker, as well as the panel that once covered the disconnect. So, just so the next guy can be safe, whether it's me or you or whoever it is, I want to make sure nobody gets hurt. So, always try to read stuff. Like I said, hopefully they do approve the quote, but what I've been noticing is sometimes if they absolutely do not need to approve something, they won't, despite me saying you absolutely need to do this because it's a safety concern. Obviously, it's not code. I need to have a service disconnect at the unit for safety reasons. But any of you guys that are in the restaurant industry, I'm sure you know that they don't always listen to us. So anyway, I'm gonna go kick this onto the breaker and we'll see what happens. We're on at the breaker downstairs. Compressor just came on, pulling 7.6 amps. We're in cooling. We should kick over into stage 2 cooling very shortly. The blower appears to be going the correct direction. Condenser fan motors are blowing. Let's see, we probably don't have a very low supply temp just yet. 85 and dropping, but literally it's been running for 42 seconds. So give it a break, guys. Let's wait for stage 2 to engage. I don't know how long the system's been operating like this, but hopefully the compressors didn't undergo any sort of permanent damage from trying to run with minimal power. Circuit number 2 is on, pulling 8.5 amps. Just kicked on a second ago. Let's see what our supply temp is like now. 69 and dropping. We're pulling back 86-degree air though. So let's let that run for a little bit. See what happens. Alright guys, that does it for this one. Like I said, we're going to quote a new disconnect, swap that out. By the time I get back, these condensing coils will be probably plugged solid with cottonwood, so we'll also recommend those be cleaned. And I also measured for our metal screens here over the economizer, and we'll get some of those on order as well. But I don't see anything else alarming. The belt looks good. I know I didn't show it on camera, but the pulleys look decent for their age. They had a little bit of wear inside, but not too concerned about those, honestly. So it is what it is for now. All right, guys, be safe out there. I'll see you when I see you. Today's issue, we have this carrier unit apparently not cooling. Although, I wouldn't say that it's not cooling. I don't know if you guys can see this, but I mean, there's lots and lots of water coming out of it. What is this, 4 ton? Or am I reading that wrong? I can't remember carrier nomenclature. But anyway, they're having comfort issues downstairs. Now, my first work order is for this one. My second work order is for the kitchen unit. I don't know, since this was in such good shape, I would almost venture to say this one's probably working, but it's trying to do the entire restaurant by itself, because that one back there probably failed. But we'll see. I can hear something running. Feels like the condenser fans are going. I'm going to pull this side panel off, see how many compressors we have, how many are running. Actually, before I do that, I'm going to take a supply temp. See what kind of air we're pushing first. And yeah, then we'll go from there. Well, rudimentary supply air testing didn't come out with spectacular results. I'm apparently only getting about 70-degree supply air down into the space. My makeup air damper, it's about 1 inch roughly. It's dirty as crap. I don't know if you guys really see that on camera, but it's pretty dirty right now. Least of my concerns. I'll grab it and wash it downstairs a little bit later. Got my cover panel off. I didn't want to turn it off without seeing this little blinky light in there. No blinkies. No blinkies, constantly on means normal operation. However, that's probably not the case since we're only putting out 70-degree supply air. So I'm going to turn it off, drop this cover, and see if I can see anything more. I shut it off. I verified both fans were spinning in the correct direction. I immediately noticed this thing, which that's new to me. I've never ever seen it before on a rooftop unit. Just dangling right there. I don't know if it's supposed to be dangling. There's a spot that it apparently goes into over there. These brown wires, looks like they might go over to that liquid line solenoid way over there. I see some oil. Filter dryer looks like it's been changed, possibly. 99% sure that's been changed, so that oil could be old. Hard to say. The evaporator over there looks like it's sweating a wee little bit. Can't really see it very well from this vantage point right over there. Huh. Well, I'm gonna have to stare at this for a few minutes and try to make sense of all this. I haven't seen a setup like this before. So, is this a heat pump? Is that acting as a reversing valve? I have no idea. Can't imagine that's the case. I mean, since it's gas fired, right? How weird. Quick visual, guys. Filters look good. I've already looked behind there and I almost dropped my phone down in the vent, so I'm not going to do that again. But yeah, I pulled the filters away. Evaporator looks good. I came over here and inspected the blower. Blower looks good. And belt looks brand new. A little bit of a ridge in the pulley. Not terrible. Not a real big fan of how deep that belt sits inside that pulley, but right now that's the least of my concerns. I got the manual out because I'm going to read up a little bit on this compressor real quick because I'm not real familiar with the 2-speed aspect of it. I mean, come on, bro. I mean, I get the basic concept, right? So we have this, which apparently is like 24 volts. Input, output, 24 volts. Rectifier inside. I mean, I assume when there's a call for 2-stage cooling, that back there would activate some sort of a solenoid or a slide or some internal mechanism that's going to allow it to fully compress the refrigerant. I mean, initially, once I had this off, my suction line was cool, not cold like it normally is. So that's what I'm going to assume it does. So once I turn it back on, I might just check this just for 24 volts just to be sure. I don't know, maybe there's an issue with it, or maybe maybe it just fell right out. Maybe it just slipped right out of there and just started dangling, and that's the issue we got. I mean, generally speaking, this unit looks pretty nice, so I can't imagine there's anything real crazy going on with it. Let's see. If I had to guess, I'm guessing this relay is what controls the what sends power to that rectifier over yonder. So I looked in the manual. Not much to go on that really explained this. That manual is more about a VRF system. This is not that. Real quick though. If you can tell by all the hot block that's on that TXV, that's been replaced before. It doesn't appear like the fixed metering device has been switched out with the TXV. I think the TXV itself has just been replaced. So essentially what happens is this little relay right here energizes that solenoid back there. I'm still looking for what exactly controls this and sends power to this. But like I said before, pretty sure that will initiate some sort of mechanical device inside there that'll let the compressor pump at full capacity in stage 2 cooling, and then we have our both of our stages cooling. But you know, the other thing that's kind of concerning is even if one stage was cooling, I should have gotten a little bit less of a supply air temperature. But yeah, we'll revisit that in a few minutes. Once we make sure that both sides are running, we'll revisit that whole idea. So what I'm going to do now is just power it on. I'm going to make sure that relay has power, see if I can hear that solenoid close, and then we're going to check this for 24 volts. So, meter's ready. Probably some sort of delay with the thermostat. It is a trained thermostat for some reason. On a energy management system, I believe. I got 24 volts to my thermostat circuit. Nothing coming back from cooling just yet. This might take a minute. Alright gang, you guys are learning right along with me in this process. So, I got 22.9 volts DC. I'm measuring in DC because I came down here and I found that it is indeed a loader, as I suspected, right there. And if you read note 4, compressor loader plug contains bridge rectifier to convert AC to DC. So I got the right idea to measure for DC instead of AC, which I was getting some DC voltage. Exactly what it should be, I don't know. But I'm getting 22 coming back on. And then the other thing I'm going to do is I'm going to check up here, right here on my control board. I'm getting 0. I might need to get my other hand on this. Yeah, but see on this black wire coming out of the board, I should have 24 volts. Right now I have it jumpered out, initiating a call, but according to the schematic, right down here on this black wire that goes into the loader, if we trace this backwards, it goes down through here, through the high pressure 2, low pressure 2, which comes off of our violet, which is just the jumper from 4 to 5, and that comes down from reheat, huh? Well, I didn't suspect that. Is that, or am I just missing something? Let's see. Follow this very carefully with our eyes, as it'll trick you. Yeah. All right, so I don't know if I was getting good connection or if I just didn't have it at the time. Let's see. So I do have the 25 volts coming out of our control board on this black wire, which goes down into our rectifier control. I'm just going to shut it down again. And that rectifies AC to DC, so I got 22.9 volts of DC right there. Let's go back to staring at this real quick. So, I think I'm just looking at the schematic wrong. Now, we don't have an economizer in this, we just got the plug. It's just bypassed over in the filter section, right? So, my Y2 signal, let's see, Y2 is right there. Field control wiring, blah, 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 goes down into terminal number 4, turns into yellow, and then the yellow goes over here, and then it just returns back on the orange, I believe. And the orange comes back over here. Where's the orange go? Where's the orange go? Orange goes right there. And from here, I'm guessing orange goes up into this. Orange comes back down over here. Fuck, would I go back that way for? That doesn't make any sense. This makes my brain hurt. Alright, so I think I made sense of this. Now, you guys who are intimately familiar with this or can read schematics a lot better than I can are probably just smashing your computer screen right now, if you even stuck around long enough to watch this. But anyway, here's what I surmise. Let's see, so we got Y2 comes down, goes into terminal number 4, yellow, goes over to our economizer bypass plug, goes up, or yeah, I assume it goes up over here, and then it comes out orange. And I thought it maybe was going into this orange wire over here, but I'm pretty sure it's going into orange number 3 when it comes back from the economizer. I could be completely wrong, but this is what I think's going on. Comes over here, goes down this dotted line, and from here it would jump over to this, which is jumper number 7, because this takes us right over to the circuit we need to be at, which is number 4, where it goes into our violet, that jumper wire that's right in between our brown and our black, and this violet would jumper it over to our low pressure, high pressure, and then it would come back into our black, and then from there it would go into our loader. Now that whole circuit seems to be fine. I'm not actually troubleshooting any of this. It just bothers me when I can't initially read something like this, and it was just a bit confusing. So that's what I'm pretty sure That's how I'm pretty sure the voltage is running. Like I said, I'm pretty sure it goes out number 4, goes through our bypass plug, and it comes back on orange number 3. I'm pretty sure. I could be wrong. If I am, leave me a comment below. Teach me something. I'm all right with learning. I'm not so prideful that I can't learn from anybody. All right, so anyway, I am thinking maybe this just wiggled itself out of there. So I'm gonna plug it back in and see what happens. Bit of a new development here, guys. I had everything running. Right now I have the loader plugged in, the little plug that I was playing with. That's plugged in to the loader right now. And I had everything running, and I was waiting for a W2 signal to kick on, right? And I never got a W2 signal. So I just put a jumper on there. As soon as I put my jumper on there, my transformer popped. Now, I've jumped out W2 before with the loader unplugged. So that leads me to believe that we have some sort of loader issue. And since it was, I don't know, whatever the amp draw of the loader is, I'm assuming that our loader is bad inside the compressor. So I'm gonna have to do a little bit more research because I'm curious to know. I mean, I'm fairly confident I understand the principles of that compressor, 2-stage compressor. We're just energizing a loader to fully load the compressor. And I assume there's a solenoid inside there, some sort of device that's inside there, right? And whatever that is, I'm assuming is going bad because it's drawing high amps. But what I don't know is how to properly check that. Like, I'm gonna ohm it out here in just a second on the compressor itself and just see. But that would explain why it was just unplugged and dangling there. So let me take this stuff down, and I'm just gonna ohm it out. I don't know what it should be, but maybe it'll stay on the compressor somewhere, but I doubt it. So yeah, try to get back here and ohm out this loader right here. The thing is I'm touching the leads, so I'm adding to the resistance with my body. Let me see if I can. There we go. I think I'm off of it now. Okay, I'm off of it now. 0.5 ohms, very low resistance. All those numbers jump around. That was when I was touching the leads. See? Moving them around. But I also checked, we're not shorted to ground in any way. So my thought process is our loader is bad. Now, again, guys, this is the first time I've ever seen this sort of setup before. But my buddy, Ty Branneman, apparently he's a little bit familiar with these. So I'm going to reach out to him, actually, and kind of pick his brain on this. But I'm 95% sure our compressor just needs to be replaced because that loader inside of it's bad. And that's based off of, I have 24 volts going down to this rectifier plug, and then I have 22 volts DC coming out of the rectifier plug, which is close to our 24 volts DC that we're supposed to have, 22.9 to be exact. So that's right. And the only thing I did was plug it in, and then I just put a jumper across to energize Y2 beforehand. Last time when I was measuring it, I did the same thing, but I didn't have it plugged in. So once I plug it in, it pops our popper on our transformer, and we lose all control voltage. So yeah, like I said, I'm 95% sure we just need a new compressor. But just to satisfy my curiosity, I'm gonna reach out to somebody who's smarter than me and learn a little bit more about that compressor. So yeah, let's see how that goes. So tune in, guys. There will be a part 2 to this, and hopefully that part 2 will entail changing out this compressor, or at the very least coming back with whatever parts that I learned that it could possibly need. But it'll most likely be a new compressor, filter dryer, you know, just the common stuff.